Hello everyone, welcome back to SCALER Academy YouTube channel. Myself Vamsi. In this particular tutorial, we will be solving first 15 days of February daily LeetCode challenge. So the level of the difficulty level of this particular challenge is going to be easy to medium, and moreover, I can say that all are concept oriented rather than just a problems. Okay, so we will be learning some great stuff like hashing. Okay, there were 4 to 5 problems around hashing, and that too including the string concepts, and there is some tree problem as well. So moreover, I felt that it's an easy level and a beginner should easily like must and should approach and like think of in a different manner how we can tackle the problems. Okay, and in this particular tutorial we will be not just entering into the solution, so we will be starting right from the a very brute force approach, and then we will be going till the optimized approach. So when I say brute force approach, what does it mean? So if you are in an interview, if your interviewer asks you to solve one particular problem, okay, so you might have seen that problem earlier, but you should not directly jump into the solution. So you should act like yes, so you will be taking 1 minute, okay, and then first clarify all your doubts. Okay, I will be like telling you how to ask question while discussing the problems as well. And then you should always think of from the very brute force approach, okay, very naive approach. Okay, what you can do, like by using 2 for loops, by using 3 for loops, and then try to optimize it by using sorting. Okay, like n log n. Just think, okay, will sorting helps you solve this particular problem or not? Okay, and if yes, then go ahead and explain that particular approach. And again, if there exists a solution which completes that particular problem in linear time, means big O of n, then go ahead and tell that approach. Okay, this is how your interview discussion should work. Okay, it's not like so they have asked you a question, you directly jumping onto the solution. Okay, so you always maintain a good rapport and good communication between your interviewer and you. That's how it works, and this particular tutorial will help you to do that. Okay, so watch till the end so that you will get some fair idea on how the problems will be asked and how to solve such a problems. Okay, and how to explain to your interviewer. That's the very most big important thing here. Okay, so I will be discussing the problem in such a way that you can discuss the same with your interviewer as well. Okay, so I highly recommend you guys to watch this video till the end. Okay, so you will get some brief idea how the interview works. And also, if you are visiting channel for the first time, I highly recommend you guys to subscribe to this channel. Please hit that like button up, and please let us know in the comment section how did you feel about this particular video. So let's discuss the February's daily challenge first problem, means day one problem. So the problem name is best time to buy and sell stock. So which is very famous and very good problem. Okay, in terms for beginners. So you can see the likes here. Okay, 14k likes. It means a lot. Okay, so let's go through the question first. So you are given an array of prices. Okay, where prices of I is the price of a given stock on the ith day. Okay, so you can assume that if you are given 0th day, then the price associated with that particular day is the price on that day. So you want to maximize your profit by choosing a single day to buy one stock. Okay, and choosing a different day in the future to sell that stock. Okay, they are saying that first, before selling that stock, you need to buy. Okay, and return the maximum profit you can achieve from this transaction. If you cannot achieve any, like you cannot achieve any profit, return 0. Okay, so if you can make any profit more than 0, then you can just return that. If not, you can simply return 0 as well. So yeah, so now let's go through these test cases. Okay, so yeah, this one. Okay, so they are so buy on day 2, so they are buying on at 1 buy, and sell on the day 5. Okay, day 5 is a 6. Okay, so sell at 6. So if you buy at 1 and sell at 6, your profit is going to be 5. Okay, so now note that buying on a day 2 and selling on day one is not allowed because you must buy before you sell. Okay, this is the note. Okay, so if you are selling one particular stock, you have to buy some stock before that. Okay, that's the golden rule, right, in general. So here you can see in this example, so 7 6 or 4 3 to 1. Okay, so if you buy at any of the day, you cannot make profit because all were there in less. Okay, stock is going in some decreasing manner. Okay, so market is too low, so if you sell that stock, even you will make a loss. Okay, so here they are not interested in the loss, they are interested in only in the profits. Okay, so now how can we solve this problem? So one way to solve this problem would be like, let's think. Okay, let's think. So in general, so what you require, okay, if you are at currently at eighth day, okay, if you are currently at the eighth day, so let's write the cases here: 7 1 5 3 4 2. Okay, so if I am currently standing at this, let's say I am buying at this guy. Okay, I am buying with the price of 7. Buy. Now as a trader, okay, if I want to make profit, if I wanted to make profit in the future, whatever I buy, I have to sell it for more than that, right? The amount which I bought, I have to sell it more than that. Let's say if I buy at 7, I need to sell it at greater than 7, means 8 9 10, then only I will make a profit. Okay, so now just check, is there any number that makes you profit? No, there is anything that is not going to make you profit, right? So if you buy at 7th, okay, if you buy at this particular day, means at 0th day, you are going to lose. Okay, you are going to mean trouble. Okay, now if you buy at the first day with the cost of 1, okay, then in future if you sell at this particular price 5, then you will make a profit of 4. And even if you can sell at this day, you will make a profit of 2. If you sell at 6, you will make a profit of 5. And if you sell at 4, you will make a profit of 3. Now out of which all, what is the maximum wala? It's a 5. So if you buy at one price, and if you can sell at 6, then you will make a 5 rupees profit. Okay, as of now profit is 5. Now let's say if you are buying at 5 rupees, now the maximum at this thing was 6. Okay, if buying at 5 and selling at 6 will give you one profit, okay, which is less than 5. Cool. Now let's go to this 3. So here 6 is greater than 3. Okay, so if you buy at 3 and if you can sell at 6, you will make a profit of 3, which is way more less than 5. And even if you sell at 4, you will make only one profit. Okay, so which is less than 5 again. And if you buy at anything at a 6, you can only have one option to sell it on a 4. If you sell that at 4, you will gonna lose 2. Okay, and buying at a 4 will doesn't give you any profit. So this is the profit that you can make. So if you can clearly observe, okay, it's just in 2 loops. Okay, let's say your outer loop I is equal to 0 to n, okay, where n will be the size, and you will be making j equal to I till the n. And if let's say profit of I less than uh, profit of j, okay, the current day is less than any of the next days, then you can say that you can sell that stock, right? So let's keep a track of max profit. So initially initialized to 0. So then you can simply say max equal to max of max profit, comma, and you can buy at this, you can sell at this. So it would be P of j minus P of I. Done. So at the end you can simply return this max profit. So yes, that works. Now let's, if you follow this approach, what will be the time complexity? At max, in worst case scenario, you will be ended at n square, right? You will be ended at n square. So obviously your interviewer not gonna interested in that particular solution. So he will ask you to optimize this. So here we have seen perspective of buyer. Okay, let's see in perspective of seller. Okay, so let's delete all these things. So let's say again write this entire array. So 7 1 5 3 6 4. Okay, now let's suppose I wanted to, let's say, so if you wanted to buy, first you need to sell. Okay, let's say if I am selling at this particular point, I need to buy at any of these things, right? So out of all the options available, which one I have to choose to make max profit? The one which is very less, like smaller among all the options available. So the smaller one is 1. So I will make a profit of 3 here. Now I will stand at a 6. Now if I wanted to sell, if I have decided to sell at 6, I wanted to buy at these options. So out of all the options, I will choose the one which is very less, right? So the one which is very less is 1 only. So then I will make a profit of 5, which is greater than 3. Now if I decided to sell at 3, then I need to buy at 1. This is the one which is very less. So 2, okay, which is less than 5. So I'm not interested. Then I will go to 4 5, sorry. Then if I decided to sell at 5, then it will be 5 minus 1 4, so which is less than 5. So again 7, like 1, not interested, you can't buy anything which is not gonna give you any profit. And again you can't buy at 7 because you can't sell at 7 because there is nothing to buy before that. Okay, so if you observe some pattern, okay, so let's start from the beginning. Okay, let's start from the 0th index to the nth, and if I am reaching to the 8th position, if I keep track of the min among all the days before that, if I keep track of the minimum buy amount, okay, then my job is done. Yes, so let's say in worst case, like what is the max profit? I can say max profit equal to 0, and minimum buy equal to that day, first day, let's assume first day, so which is a pro of 0. So if you are putting 0, then we need to check whether the size of the profit is gonna start at 0 or 1. So yeah, it is 1. So you are going to have a 0th index for sure. Now you need to check max profit first. Okay, max profit equal to max of max profit comma, so you decided to buy at this minimum price, right? So minimum, oh sorry, it would be like the current standing, like sell price minus minimum buy, done. And now you need to check whether this is the minimum, or like you need to keep track of minimum element, right? So minimum buy equal to min among the current profit, like current element, or minimum buy. That's it. Okay, you just need to keep track of minimum element, that's it. So now if you could carefully observe, the time complexity is gonna be a big O of n. Okay, which is some good. Okay, makes sense, right? So your interviewer will get accepted. Now let's simply go and code this up. So let's first let's try out okay, max profit initialize to 0. Okay, let me make max profit, then min by equal to prices of 0. Now I need to traverse through all these elements, so it would be like int current price, now I need to check first profit equal to max of profit that you gonna make. Okay, if you sell at current price, okay, current price minus minimum buy, right? Minimum buy. And then you need to keep track of your minimum buy. So minimum buy is equal to minimum of buy, comma, the current element, okay, the current price. Okay, done. So at the end you can just return max profit. Okay, let's see. Yes, get accepted. So if you carefully observe, the time complexity of this approach is going to be the number of prices, means a big O of n, okay, where n will be the size of the given prices. Okay, so done. So let's solve a day 2 February daily challenge problem. Okay, so the problem name is find all anagrams in a string. So let's walk through the question first, and then let's try to understand that, and then we'll move on to the coding part. So you will be given, okay, so given two strings s and p, okay, return an array of all the elements, yes, so yeah, vector, and starting indices of p's anagram in s, okay, and you may return the answer in any order. So means the indices could be in any order, and an anagram is a word or phrase formed by rearranging the letters of a different words or phrase, typically using all the original letters exactly once. Okay, so let's first understand what is an anagram. Okay, so let's say anagram. Okay, let's say I have a name Vamsi, and I have another string called this, yeah. So let's assume this is S and this is P. Now tell me whether I can make S with the P. Can I? So if I wanted to make that, okay, if I wanted to convert this P to the S, what all I can need? So I need what are all the characters present in my S that should be equivalent to the P with along with the frequencies, right? Okay, frequency of characters, frequency of characters in S should be equal to P string. Okay, that is the thing. So now let's check whether frequency of this S and P are equal, and if that is equal, then we can make this as a like we can convert P as a S, and we can say that it's a anagram. Okay, let's see. So here in this, V has occurred once, A has occurred once, M has occurred once, S has occurred once, I has occurred once. Now, so what all I need? One V, yes, which is there. One A, yes, it is there. One M, it is there. One S, it is there. One I, it is there. Now I can say that I can convert this P to the S. So I can say that this is an anagram. Both S and P are anagrams. Okay. So how can you solve anagrams? So it's very simple. Okay, you can either check, you can maintain hash, okay, where you will be maintaining the frequency of each character, and you can cross check the same with two strings. That is one way. And you can simply sort both strings. Okay, if you sort Vamsi, you will get a m sorry a I M S V. Okay, if you sort this thing like this P, you will get A I M S V. So both strings are equal, right? So that if both after sorting, if both the strings were equal, then you can say that that's an anagram. Okay, so these are two ways that you can do. Now let's come on to this particular question. So what they were given is Okay, so they will be giving S and P. Okay, so you need to find how many, or like you need to find the starting index of an anagrams. Okay, type P in the S. Okay, let's say here ABC. Okay, so you need an anagrams to make this, to convert, to make an anagram. So you need the size of 3, right? Like means these piece characters all should be in S as well. So 3 size. Okay, if you consider all 3 size. Okay, here let's see. So if you consider this, so you can you make anagram here? Yes, CBA ABC. So we have all the frequency. Okay, so you can make a anagram here. So now what is the next 3 size substring? So it's a BAE. So you can't make, right? So C is missing, so you can't make. So again, that if you consider next sequence, then AEB. Okay, you can't make anagram over there. Okay, what again? So you have made one anagram at 0th index. Okay, and you can make another in anagram at this BAC. Okay, which is at 6th index. Okay, so this is how a algorithm, like explanation of this particular program goes. So please pause the video for a while, okay, before jumping on the solution. So please give it a try on your own. Okay, so now let's discuss the solution for this. Yeah, so let's say, oh, let's think first of all, let's discuss about brute force approach, what you can do. So here you can do something like, you can generate all the substrings. Okay, so like starting with the 0th index. Okay, let's say here let's consider this small example, a b and AB. So let's say, so from ith from 0th index, let's make the size of the substring with the p size. Okay, p size substring. So if you consider p size substring, yes, this is one substring. Can you make this as a anagrams? Just check. Yes, you can make. So you can include the index of the current thing. So if you check, it will be 0th index. Now let's move on your pointer to here. Okay, now check what is the size here, 2. So let's consider 2, and it's a BA. So you can make an anagram here. So it will be 1. Then you can go to here and you can check again. You can make a anagram. So you can make 2, and you don't need to go to the rest of the arrays, because whenever you go, it will be the less than the size of p, right? Like you will be required 2 characters for sure. Here you will be having only 1 character, so you need not to traverse through entire like end of the string. So if you traverse through n minus m, so where n the size will be this string and m will be size of this string. So yeah, like if I write the pseudo code, it would be like something. So for I is equal to 0 to n minus 1, and I need to generate to the next like j equal to 0 to like I to m. Okay, m size. Then you can just maintain a temporary string, and you can add all the strings of that particular size. Okay, s of j, and after coming here you can just check. Okay, is anagram. Okay, is anagram of temp comma p, and if it is true, you can make an like, so you need to maintain answer vector. So answer dot push back the I. That's it. Okay, it will do. Okay, now let's analyze the time complexity of this particular approach. Okay, so the time complexity of this approach would goes like, so here at max you will be, let's assume, okay, so here you will be traversing till n minus m into, and all the substrings of the size m. Okay, so let's make it as an m. So you can say it will be more or less n into m. okay, and inside that you are again checking is anagram. Okay, so if you are using an hashing technique, then it would be big O of n, and if you are using sorting, then it would be like n log n. Okay, so that complexity is very high, right? So big O of n, big O of m into n plus each time you for n minus n times you are doing sorting or hashing, so it would be more. So your interviewer will not happy with that particular solution. So what next? You need to optimize the solution. Okay, so here to optimize this particular solution, there is a one good topic to learn. Okay, that topic name is window sliding. So if you observe the pattern here, if you don't know anything about window sliding, it's okay. So you might not hear this particular term, but you could have solved some problems if you're here. Okay, so let's see. So if you observe some pattern, okay, so let's say if you take the C, B, A, E, B, A, B, A, C, D. Okay, so and A, B, C. What are all you need? You need the substring. Okay, you need the substring. So at first it would be ABC and CBA, right? And next you need to eliminate this C and you need to add this E. Yes, you need to eliminate this C and you need to add this E. Now, so I like, because you need only the size of 3 and that too in a same pattern. Okay, you can't skip these some characters and you can't jump. Okay, it should be substring. Okay, so with the equal, okay, the next characters. Okay, so in that case what you can do, so if you observe carefully, you are doing one minus and you are doing one plus. Okay, this is plus. Now if you wish to go on to the next thing, then you are eliminating the B and you are adding here, right? So if you see such kind of patterns, okay, you can use this window sliding technique. Okay, so don't worry, it's not that much complicated it seems. Okay, so let's try to figure out what it is actually. Okay, so I will take a small example. Okay, so this one, AB, AB, and AB. So this is S, this is P. Okay, cool. Now let's try to figure out all the windows with the size of 2. So I want AB. Okay, so at first it would be AB. So AB, this is correct. Okay, and then this is correct, then this is correct. Okay, so if I push all the indexes which were correct, then it would be 1 0 1 2. So this is how it looks like. Okay, it's very simple to code as well. Okay, so you haven't tried, it's okay, let's see. So at first let's try to get the sizes of the given strings. Okay, n, so s dot size and int m equal to p dot size. So now let's look at the constraints. Okay, so if n and either n or m equal to 0, then you need to return something, right? So by God's grace we are given the size of starting with 1 at least. And one thing that you need to identify is they have mentioned that the upper limit was 3 into 10 power 4 for both and lower limit was 1. So either of the things could lies in between that. Means let's say your P might be greater than S as well, like P size can be greater than S as well. In that case you can't make the anagrams, right? So in that case you can simply return something. So if your m greater than n, you just need to return empty vector. Okay, empty vector. Now done. So for all other cases we need to figure out the answer. So for answer we can say vector create answer. Okay, where we are returning that answer and pushing back all our indexes over there. And now we need to create an hash. Okay, so here to find anagrams I am using hashing technique. So yeah, which is which took linear time. Okay, so let's say, so if you don't know, like if you don't get confused, Okay, so here I am using term called hashing, but I am using vector. How can you do that? Okay, so you can take the advantage of alphabets here. Okay, characters, you know, right? So we will be only having 26 alphabets. Okay, so if you took hashing map or something, it sometimes it might get into the login time, but you if you considered arrays or vectors, it will be constant. Okay, if you wanted to access, it will be constant. Now how can we store? So for any number, if you are for any character, for any character, okay, if you are dividing, let's say s minus a, okay, so s will have some ASCII value, and a will have some ASCII value. If you divide that, it will come out of as a 0th index based thing. Okay, so you can use that technique. Okay, so yeah, now first let's say hash s, and with the size of, we know the fact call, we will be having only 26 characters. So I will be filling that with zeros, and again I will be creating another hash with the hash p, again with the size of 26 comma 0. Now what I need to do, at first I need to go and hash my p and s with the first window. Okay, so first window size I need to hash, right? So let's say for I is equal to 0, hash of s, okay, hash of s, and the s of I minus a. We will be just increasing the frequency over there, just that's it. Okay, hash of p of I minus a. That's it. You have hashed your first window, and after that you need to check whether that windows like vectors are equal or not, right? So that for that you can use the advantage of vectors here. You can directly use equal to, okay, hash p. So both were equal, you can simply push 0th index, 0th index to the answer, right? Because we started at the 0 only. Okay, whatever we have as of now or the first window size. So first window size will be, starting point would be 0. Okay, now we need to process for the rest. Okay, so let's start. So we need to start where we have ended. So actually if you consider the sizes m and n, right? So we know that fact that n is always greater than m. Okay, now we have hash it till n. Okay, so if you carefully observe, if the size of the m is 3, then we will be stopping at the second index only. So we need to start from the third index. So I will say m, then I would be less than n, then I plus plus. Now what I need to do, so if you remember, I told two things. Okay, one is leaving at the beginning, and another one is we are adding. So we need to leave something for the s. So for that, what would be the index? So every time I need to remove the Windows first element. So here if you carefully observe that here the Windows first element would be the index 0. So I will create an one variable called leave is equal to 0. Okay, or leave index is equal to 0, and I will say leave the character of that particular index. Okay, s of that particular index. So leave index minus minus. So we are just decreasing one count of that particular character, and then we need to add the current value, right? Current hash value. So let's say s of I minus a plus plus. Okay, after all that we need to increase our index, so to the leave index to the next window, and here we need to check for one thing. What is that check? So here hash of s double equal to hash of p. If that is equal, we need to push that index. Okay, we need to push that current starting window index. So what would be the current starting window? So it is not I, as you can guess. Okay, if you figure out, if you carefully observe, you will come to know it is not I. So if you carefully observe, it would be something like I m, okay, I minus m plus 1. So do some math, okay, you will get it. Okay, so otherwise let me explain that as well. Okay, let's say you are currently standing at 3 third index. Okay, and you have considered, and you have leaved a 0th index over there itself. Okay, now you figure out that the window starts from 1 is what the window beginning as of now. You need to push that to the answer. Okay, so here the I size is 3. Okay, so if that happens, then it would become 2, right? Like currently your I is 3. Okay, your currently I is 3, and then you need to remove the all the elements. Okay, all the characters count, whatever whatever present in the piece size. Okay, because you have considering all the, you are skipping all the m characters, right? M indexes, so you need to remove that m indexes. So m is 3, and you need to add 1. That's it. Okay, it will come out of as a 1, so which is the current starting window. So that is formula for it. So after all doing all these things, so yeah, okay, at the end you just need to return your answer. Okay, so let's try. Now let's try to figure out the complexity of this approach. Okay, so if you carefully observe, so here we are iterating for the m times. Okay, here we are iterating for the m times, and here we are again iterating for the n minus m times. Can I say that n minus m times? So if you total it, okay, if you total it, like it would be like n plus m, then m and m will get cancelled, and you will be ended up with n times. Okay, so I can say that the overall complexity would be big O of n. Okay, and here if you carefully observe here, if just suppose if this particular feature is not there, and what we need to do, we need to iterate through and loop, okay, for the constant time of 26. Okay, and then we need to check with all the indexes whether that particular character frequency is equal to, both are equal or not. Okay, then it would have cost us 26, right? Constant. Okay, so or I can say that then the overall complexity would be big O of n into 26 times. Okay, then that's here comes the space complexity. So here we can say that it's a constant space, because whatever the size of the strings you are getting, you will not be changing those sizes. Okay, so you are keeping that as a constant, so you can say that constant. And if they were if you want to be too particular about it, then you can mention it as a big O of 26 plus 26. Okay, so that's all it. Let's solve the day 3 diety challenge. Okay, so let's the problem name was Foursome 2. So basically Foursome has different variations, and this is second kind of variation. Okay, let's see. So given 4 integer arrays, okay, num1, num2, num3, num4, all of a length n. Okay, so they will be giving you 4 arrays or vectors, and with the size of n each, and return the tuples, okay, I, j, k, l, such that okay, so this is length. Okay, and this is the condition. So here the condition is, so if you add up the ith index, jth index, kth index, and lth index, okay, from the respective arrays, and they are representing I for the num1, j for the num2, k for the num3, and il for the num4. So if you add up all those numbers, then it has to be turned out to 0. Okay, so you need to simply return the count here. Okay, you need not to return the tuples. Okay, so since it's an integer type, return type, so it will be good if you only return the count. Okay, so if you can carefully go through the given examples, so for the num1 they will be giving you 1 2. Okay, they will be giving you 1 2, and second array it will be -1 and -2 and -1, and third it will be -1 and 2, 4 it would be 0 comma -2. Okay, so they are saying that add a 0th index, 0th index, 0th index and 1th index. Okay, so they are adding this and this. Okay, so if you see -1 and +2, sorry, -2 and +2, -1 +1, so yeah, it will be turned out to 0. Now they are adding 1 1 0 0, so this one and this one, and yeah, this one. So it is going to be -1 and +1 and 0. Is this what they are doing? Nums of 1, yeah, nums2 of 1, yes, it's -1. So yeah, it is going to be this, and sorry, yeah, -1 only, then a plus this one. Okay, again it is going to be minus, and yeah, at the last it is plus. Okay, so -2 is equal to 0. Okay, so then the count here is 2. Okay, cross checked, and yeah, so this is the problem. Okay, if you carefully observe here, one thing you need to identify is, you after seeing this problem you might think that yes, I have solved this kind of problem, but it is not actually. So as I said, there are different variations for it. So here they are not interested in the order of the I, J, K, L indexes. So if you carefully observe for the foursome one, they might be giving you like this. Okay, so where Lth index, the index of I must be less than J, and Jth index must be K. K's index, kth index must be less than L. Okay, so you need to consider the indexes in the increasing order only. All the indexes there would be distinct. Okay, but if you see this example, they are not, we don't have any such kind of constraints. Okay, so indexes might be anything. So the combination, the chances of combinations has been more here. Okay, so now pause the video for a while. Now think about a solution. So how can we think? So let's think. Okay, let's start with the very brute force approach that everyone can do. So let's maintain 4 for loops. I is equal to 0 to n, j equal to 0 to n, since we don't have any constraints. Okay, so we are starting from the 0 0, like we are considering each combination, every combination, possible combination. And next, k equal to 0 to n, and for L equal to 0 to n, and you will sum up all the values. Okay, you will sum up all the values and you will check if sum double equal to 0, just increase the count. At the end, just return the count. Yes, it should work, right? Now if you go and submit this problem, for this particular input it will accept. Okay, but if you go and submit it again, it is going to throw an time limited exceeded. So why? What is the time complexity of this approach? It is going to be n power 4, right? N power 4. So if you see the constraints, the given constraints were around 200. Okay, so 200 power 4 is nowhere near. Okay, so it is not going to accept the solution. So what is the next thing that we need to do? So we need to trim this down to the n cube. Let's try that, whether we can do that or not. Okay, so now let's assume you are given only one vector. Okay, you are given only one vector and asked you to find the sum. Okay, asked you to find the sum. like two elements, sum of two elements, sum of two elements where value equal to 0. Okay, equal to 0. Now you can do this, right? How can we do this? So we can make very first approach would be n square, and then you can sort out and you can use two pointer approach. Okay, and then the optimal solution would be use hashing. Okay, using hashing. So now let's think of something like, so can I say like the idea is adding up all these values, right? So if I say this could be done by using this particular approach, yes, yes, that can be done by using this particular approach. So if you apply that same theory here, it is going to be for this you require n square, and for this you required again n. Okay, n. So at the end it is going to be n cube. Okay, n cube. So again, if you go and submit this solution, it won't accept. Okay, again it will ask you to optimize it further as well. So now here comes the picture. Okay, what you need to do. So let's say, let's do some math over here, is equal to 0. So this is what they want. Okay, and if I say, can I convert this logic to something? So x and y and equal to 0. Done. So what I'm trying to do is I'm trying to find these particular matches, like all the possible values sums. Okay, so you can use n square and you can find all the possible sums over here and you can put them in the map. Okay, done. You at that time you will get x. Let's assume. Now so do the same for the num3 and num4 as well, and let's assume you are done that and you are not so let's stick to this. Okay, so now you need to do this part. Okay, means y, you need to find the y. So can I write something like this? Yes, can I write something like this? So all I need to do is, so I got this actually. Okay, I got this particular part. Now the only thing I need to do is go and find, like, so I have all these values in my map. Now let's say if I have 4 in my map, now to make this sum, okay, to make this sum, let's say x is equal to 0, I need to find the x here. So can I say x would be this? Yes, right? So minus 4 minus 4 is equal to 0. So the same works here. Okay, so I need to find the minus x. If I find the minus x, then done. Okay, so the idea is to first spin up, have two for loops and find all the combination of sums that you can make and store them in the map. Okay, now you have all the combination of sums in your map. Now just go and iterate to the num3 and num4 and find all the combinations, and all you need to do is count plus equal to map of k plus l. So like here I am putting for k, you need to put ms3 nums3 of k. So okay, I'm not doing that, I will do that in code. Okay, now what you need to do, you need to minus it from the I plus j, right? So you need to put minus here, and yeah, this is what you wanted. So at the end you can simply return count. Done. So if you want, I can, let's do some dry run here. Okay, so if you still haven't got it, let's say, so here we have 1 comma 2 and a 2 minus 2 1 minus 1. Okay, let's do some math. Okay, so here this is this, and yeah, this is this, and the next combination that I can do is, and Yeah, this. Okay, so here the answer would be -1. Here the answer would be 0. Here it could be 0. Here it could be 1. Okay, so I'm going to make an I'm going to make an map. Okay, so if I assign it to the map, then it will become -1 one times, 1 one times, 0 two times. Okay, now let's take these num3 and num4. Okay, -1 and 2 and a 0 comma 2. Okay, so if I try to find all the combinations, so -1 2, sorry, -1 0 and -1 2, my 2 my plus 0 2 plus 2. Okay, so at the end like I need to figure out, okay, so minus, I need to multiply it with the minus. So here I will get -1. So if I do 1, right, I need to do find the 1. So minus into -1, so it's a +1, and here I will get 1. So if I append 1, then it would be 1. Then here I will get a 2, so it will become -2. Here I will get 4, so it will become -4. Now find the how many, let's say, how many times this particular one has been repeated here. It's one time, so my count will initially 0, it will become 1 now. Now tell me how many times this -1 has been repeated. One time, so my count will become 2. So how many times is 0 or -2 has been repeated? 0 times. Now -4 has been repeated 0 times, so at the end my count is going to be 2. So this is how. Okay, now let's simply go and code this up. So at first we required n would be an num1 size. Okay, and they were given that length of the all the vectors were n itself. So let's go and find the sum of the first two vectors. And all you need is here is a map. Okay, let's go and create that map. Okay, let's say call it as empty. Okay, so now you need to do num1 of I plus nums2 of j. Okay, increase, yeah, plus done. Okay, now you can assume that you have all the combination of num1 plus num2 array. Now you need to declare a count variable. And now again you need to iterate over the loop. So yeah, so int I equal to 0, I less than n, I plus plus, then I is equal int j equal to 0, j less than n, j plus plus. Okay, now what you need to do, you need to simply append the their values, like whatever you need to minus and nums3 of I plus nums4 of j. Okay, done. So at the end what you need to return, you need to return the count. Okay, now let's go and submit this. So yeah, it is accepted. Okay, let's submit this up. So I tried to first submit it in n3, sorry, n power 4, then I have optimized it to the n3. Okay, n power 3. Yeah, I got I know that it won't work, but yeah, I still submitted, and I did some mistake over there, so it gave me wrong. and then I try to optimize it to the n square, which is this code. Okay, so if you can carefully observe, so here we are iterating for n square. Okay, and again here we are iterating for the n square, so I can say that overall complexity is big O of n square plus n square. So if you take asymptotic notation, it will be big O of n square. Okay, because we only consider the upper bound. Okay, so in coming to the space complexity, here we are using a map. Okay, so yep, you can say at max we are storing the n elements. Okay, if all the values were distinct. Done. So let's solve another problem in the February daily life challenge. So the problem name is continuous array. So problem number is 525. So this is a medium level problem, and yeah, it has 5k likes, so it means that it's going to be awesome problem as well. So yep, let's go to the problem statement. So given an binary array, so what does this binary array means? You will be containing only ones and zeros. Okay, ones and zeros. Num, okay, return the maximum length of the continuous subarray with an equal number of zeros and ones. Okay, with an equal number of zeros and ones. So they are asking us to they will be giving us a binary array, okay, which contains only ones and zeros, and we need to return the continuous subarray, okay, whose like in that particular subarray we need to have equal number of ones and zeros. Okay, then we need to return such kind of maximum length subarray. Okay, so here if you observe, it is going to be if I consider whole subarray, it is going to be 1011, so it is going to be 2. Yes, now this time it is going to be either this one or this one, right? So it is going to be 2 as our answer. Now please pause the video for a while. So think of come up with a brute force approach. Okay, brute force approach means just forget about complexity and all. Okay, just think of and come up with a solution that you are able to solve this problem. Now let's see. So here I will be taking in some big size array. Okay, for this output should be the 6. Okay, so here if you consider this starting from here, and yeah, if you consider this subarray, this is going to be the maximum one, and if you consider this subarray, again it is going to be 6 and 6. Okay, out of this maximum is 6. Okay, so you just need to return the length. Okay, you need not to return the subarray, right? So you can just return the 6 as your output. Now what will be the brute force approach that you can come up with? Then first thing I can say generate all subarrays, generate all subarrays, then count zeros and ones. Okay, so if you are taking something like n square to generate subarrays, and to count it, if you are taking again big O of n time, then at max. Okay, so it is going to be big O of n cube at max. Okay, and you don't need any extra space as well. Okay, this is the very brute force approach. Now just try to eliminate this one particular n. Yes, you can write. So in while keep tracking of the second pointer in the for loop, you can just maintain two variables where count zeros and count 1. Okay, and if you are able to like whenever your current pointer is equal to 0, then just do count 0 plus plus and count 1 plus plus respectively, and after coming out of that inner loop, just check whether both are equal. Then you can just do j minus I, then you are able to fill up, I guess. Okay, so you can just keep track of the index as well, so that you will get to know. Okay, you can do that. Okay, so it is going to be big of n square. Okay, you need not any extra pointer over there. So still it is going to be bigger, right? So your interviewer will be not satisfying with your answer, so he will ask you to optimize it further as well. Okay, so for that what you will be doing, so let me rewrite the whole array again. So 1 1 0 0 1 1 0 1 1. Okay, so here the technique here is a prefix count. Okay, prefix count. So what is a prefix count? So basically I'm here, right? I'm here. So first change every, like all zeros to the -1. Okay, I will tell you later why we have done that. Okay, so convert all the zeros to the -1, so it will become 1 1 -1 -1 1 1 -1 1 and 1. Okay, so convert all zeros to -1. So why we have done that? So basically now my idea is to, whenever you have seen an 1, just do +1, and whenever you have seen -1, just do a -1. That's it. Okay, so in that case, let's say currently my sum is a 1. Okay, now I came till here. Okay, I came till here, my sum is going to be 1. So I will just check. Okay, so I will just check. So if my current sum is equal to 0, yes, okay, I will tell you why. Okay, so let me continue with the algo. So again I have seen 1, so I will do +1. Now I have seen 1 here. Okay, now I have seen 1. So till now we have got 1 1 here, and again we got 1 here. So it means that whatever we have done so far, okay, like can I say we have added 1 and we have decreased 1. So if we added 1 and decreased 1, when can we do that? When and if and only if we have seen 1 1 and 0. So can I say that this is going to be one subarray where a 1s and 0s are equal? Can I say that? Yes, I can say that, right? So to keep track of these kind of elements, so we will be required a map. Okay, we will be requiring a map. Let's say we have a map here. So a key is going to be our values. So 1. So here at first I will maintain an value as 0, so index. Okay, then I have seen it 2, so I will maintain it as a 1. Now I have seen 1 here, so I will just check. Okay, when did I, so I will just check whether I have previously I have made a sum of 1 or not. Yes, in my map, so I have made a 1. So at what index? It has index at the 0. So it means that whatever I have done so far in the middle, all were equal operations. Means if I have taken +2, then if I have done -2, then only I will get a same value, right? So I will just do that thing. Okay, so I will just maintain and count the length. So initially it is going to be 0. Okay, now I will just check, like now I have got a pair. Okay, so which is there in map. So I will just check the index is 0. Now my current index is 2. So in between how many elements are there? 2 elements. How can I get that? It is going to be I minus, I is current index, and map of the current element, right? So it is going to be the sum, current sum. So in that case I will get that. So here I minus value is it is going to be 2 minus 0, so value is 2. So now since I am keeping track of maximum 1, so I will eliminate the 0 and like I will override the 2 here. Now I will just keep on. Now again I have seen -1, so I will do -1. So here I will get a 0. What does it mean? If I get a 0, again what does it mean? So whatever I have added till now, whatever I have added till now, all were equal operations, like sorry, here, all were equal operations. So everything got cancelled. When everything got cancelled, whenever I have seen an equal number of ones and equal number of minus ones, right? So in that case, I can say that like if I have seen a 0, okay, it means that whatever index I am and starting from the 0, okay, so I have added all the numbers and I got the 0. So I will say that maximum of, okay, maximum of I, okay, maximum of I, yeah, I plus 1, sorry. So if you are currently standing at third index, you might have included 4 values, right? So I plus 1, so I plus 1 is, I is currently at 3, so 3 plus 1 is going to be 4, so which is max number. So I will overwrite 4 now. Now I will go again here, okay, now it is again plus 1, so I will do 1. Now I got 1 and I will check whether this 1 has been already occurred or not. Yes, it has occurred, right? So when did it got occurred? It got occurred at 1th index and it got occurred at 0th index. Which one do we consider? Which one do we consider? We are looking for the maximum one. So out of these two, when will I get maximum one? The very first one occur, right? So the one very first occurred at 0th index. Okay, so I am not updating the map again. If I get a value, I will just use that, that's it. I won't update the map values. Okay, I will just update if I am seeing for the first time, then only I will update that. Okay, now I will just do like I have occurred at 0, so I will do, so current I is equal to 3. So let me write 1 3 4 okay, 6 7 8. Okay, so currently I am standing at 4. Okay, so 4 minus 0, it is going to be 4, right? 4 minus 0, it is going to be 4. So 4 of 4, yes, 4 is maximum, so I won't override that, and I will come here. So again it's a 1, so I will do plus. So now my index is at 5. So is 2 occurred earlier? Yes, occurred earlier at the first index. So now 5 minus 1 is going to be 4. Again I won't override. Okay, now I will go here. Now minus 1, so I will make it as a 1. 2 minus 1 1. Now I will just check whether 1 got previously occurred or not. Yes, it got occurred. What is the farthest point it got occurred? It got occurred at the 0th index. 0th index, okay, which as our in our map. So what I will do, I will do 6 minus 0. Okay, so it is going to be 6, so which is a greater than 4. I will override and store 6. Now I will move on. So it is going to be 1 plus 1, it's going to be 2. Now I will just check whether 2 got occurred earlier or not. Yes, I have seen this. At what index? At what farthest index? It is at 1. So 7 minus 1, it is going to be 6. So yes, I have in 6 already. Then I don't care about 6 again. Now I will come to 1. So I will get a 3 here. So did 3 got occurred earlier? No. So what I will do, I won't do anything. Okay, I will just update that index, the 8. Now after that there is nothing. So what is the count length that what we have? It says 6. It says 6. So this is how we are going to solve this problem. So still if you haven't understood, like, or you are looking for intuition, I will tell you that as well. Okay, let's say you have an elements something starting from here and you have came till here. Okay, so here whole sum is k. Okay, whole sum is k. Now till now you got sum as x. Okay, you got sum as x. So if you do k minus x, you will get this particular sum. Yes, k minus x, you are going to get the particular sum. So I can say that whatever values you have seen so far, if both these values are equal, okay, I can say that k minus x is going to be 0. Means whatever you have added and whatever you have deleted is going to be same. right? So if you want, I can show you the example as well. Let's say I have added a, b, and a and b, okay, minus b, and let's say I have another a here, okay. So if I want, if I am considered the whole sum, it is going to be like all the values. And if I consider, so whenever I have seen minus a, I will cancel it, b, b. Now it got till here, it got an sum of 5, okay, sum of 5 or 1, okay, 1. So here also it's a 1. So why we got 1 here? Because of we have all deleted all of these things, okay, we have deleted all of these which are equal, right? That's why we got 1. So both the values are equal. So that's why whatever the values we are in the middle, we will be counting them, okay. Now this is one intuition, and another one is whenever our case sum is going to be 0. So if I got my sum till here is equal to 0, it means that whatever I have added till now all are equal. Let's say a, b, and minus a, minus b, okay. So here I got a 0, okay, here I got 0. So it means that a and minus a got cancelled, b and minus b got cancelled, then only I will get a 0. Yes, so I can say that I have from the 0th index. So where did I coming up? I'm coming from the 0th index, okay. So I can say that, so starting with the 0th index, adding till the kth like current index is as yield 0. It means that all the indexes, like all the values till now I have seen that both are equal, okay, which are making a sum of 0. Yes, so this is the intuition behind this particular algorithm, okay. Now let's quickly go and try to submit our solution. Let me zoom in. So first we will be required an n, so n dot size. Then we will be required an variable to keep track of our max length. Max length is equal to, as of now it's at 0. Now we require a map to store our mappings, comma int, so empty. Now yes, we need another variable to maintain our sum, right? So I forgot to tell you one thing, okay. So at first we have replaced all the zeros with the -1, so we don't need to keep, okay. So let me, so here, so if we do follow this, what will be the time complexity? At first we have traversed to all the array at once to make our zeros to the -1. So big O of n plus again we need to traverse that again n time. So which is going to be big O of 2n, okay. So like here, so can you think of, we know the fact called we will be having only ones and zeros, okay. So if you have encountered, current index equal to 0, what you can do, you can just simply do -1 for the your sum, right? So so that you can eliminate this extra big O of n, then your total complexity will come down to the big O of n with the time complex space complexity of big O of n in the worst case, okay. Let's go. So now I will just start iterating over the array plus. Now if I have encountered my current nums of ith index equal to 0, okay, if it is equal to 0, then sum equal to sum plus sum equal to sum minus 1, right? Else what it will be, it will be sum plus is equal to 1. Done. Now what we need to do, we need to check if our sum equal to 0. If it is equal to 0, what does it mean? it means that whatever we have added till now is yielding the sum. So like max of answer comma I plus 1. Okay, so and after that we need to check, okay, we need to check if the else if, okay, we can put else if can just find, okay, if it is as occurred earlier or not. Okay, so how can we check if sum are not equal to map dot in. Okay, if it has not occurred earlier, then like if it has occurred earlier, then it is going to be max of, okay, max of like answer comma I minus map of this sum. Okay, done. So else what you need to do, if it has occur, if it is not 0, and if it has, and if it has hasn't occurred so far, you need to do include that in your map. Okay, you need to include that in your map with the current index, okay, where you have found. So after doing all these things, you can simply return your answer. Okay, so where your answer, okay, now let's run this code. Right, done. So now as we discussed, that time complexity of this approach is currently big O of n. Okay, and after assuming that another map is taking only big O of 1, and yeah, space complexity is going to be big O of n at max. Okay, so done. And let's solve another problem in the February daily LeetCode challenge. Okay, so the problem statement will be given something like this. You will be given an integer array, okay, sorted in non-decreasing order. Okay, remove some duplicates in place such that each unique element appears at most twice. The relative order of elements should be kept as same. So they are saying that you will be given an array which is sorted in non-decreasing order, means it has been sorted in the increasing order. Okay, and you need to replace the some duplicate, you need to perform some operations on in place, means you can't retake, like you can't return any other a new array or vector. Okay, whatever the vector you were given as an input, you need to perform all the operations on that particular vector itself. Okay, such that each unique element appears at most twice. Okay, so they are saying that you might have many duplicates, but what you need to do some in place operations where at max each element has to be occurred only twice at max. Okay, at max twice means it can be 0, it can be 1, it can be twice. Okay, the relative order of the element should be kept as same. So it is saying that, like, relative order in the sense whatever the order which you are given, like increasing order, you should maintain that particular order throughout the operations as well. Okay, since it is impossible to change the length of the array. Okay, so at the end you need to return the index. Okay, the last index where you have swapped all the, like where you have performed all the operations in place. Okay, so they are saying that it will be tough to keep track of in place operations. So if you like if you just return the index of the last element which you have performed operation, then we'll print the elements till that element. Like let's say here I have returned the index 5, so they are going to print all the just all the elements until fifth index. That's it, that's how it should work. So this is the given statement. Okay, so like sample inputs. So nums array has been given something like this: 1 1 1 2 comma 2 comma 3. Okay, and then your output should be 5. okay, means index 5. So you need to perform some operations on in place, like given this, like you need to modify this particular input vector itself, okay, where you can have at most twice a element can repeat twice, okay. So 1 comma 1, 2 comma 2 and 3, and your function should return k with the first 5 letters of numbers being 1 comma 1 comma 2 and 3 respectively, okay. It doesn't matter what you leave beyond the returned k. So that is it, okay. And if you just go through this particular example as well. Now let's get started with our approach first. It is going to be little lengthy, yeah. So let's take one demo thing, like 1 comma 1 comma 1 2 comma 2 comma 3. The very first was that comes to my mind when I saw this problem was uh, we are just very clear that we need an element which is occurred twice, okay. If we can, like, again we know that array is in sorted and increasing order, okay. So we can take these advantages sorted, okay. So then we can just figure out our logic, okay. So if I keep track of my occurrences of an element of last element, then I can solve this problem, okay, just by using new, okay, like I will be taking one temporary vector, then I am performing like I will be storing all my answers here. At the end I will be just modifying my like input a vector, okay, and returning the length of this temporary vector. So let's see, okay, how this particular thing works. So at first I will be storing this guy like a 0th index guy. So let's say I have a temporary vector. This is my vector, like temporary answer, and I will be taking care of last element and the count as well, count of last element. So at first I'm pretty much sure that this is going to be in my answer, so I will put that here, and my last element would be 1, then occurrence of that will be 1 as well, okay. Good as of now. So I will start iterating from this particular number, means element, okay. Now I will just check whether this particular number is equal to my last number. Yes, it is equal. So basically there will be two cases, if it is equal and if it is not equal. So if it is equal, what do I need to do? I need to increment my last count, okay. So I will make my counter as 2, okay. Now what do I need to check? I need to check, like, I can have at most 2 occurrences of a same element, right? So now I will check. So current last element count is equal to less than 2. Yes, less than or equal to 2. Yes, it is less than or equal to 2. So what I will do, I can just print the, like, I can push the last element onto my temp answer. So I will push that, okay, done. Now I will go to the here. Now again it is equal to the last element. So what I will do, I will go and increase my count. So it will be now 3. Now tell me, should I include this 1 again in my temp answer? No, I can't, because the count, if I put that last element in my temp answer, my count is going to be greater than 2, so which is not expected. So I won't do that, okay. I won't do that. Now I won't even like nothing doing here, just moving on to the next guy. So here 2, okay. So last element is not equal to 2, like not equal. So what I can do now, I will go and update my last element, and I will update my count equal to 1. Now I will just check whether my count is equal to less than or equal to 2. Yes, it is. So I will push the last element, which is 2 here. Now I will go to next element. Now again I will say that I can see that a last element is equal to current element. So I will increase my count to 1. So it will be now count equal to 2. Now again it is less than or equal to 2. So I will push the 2 again, means a last element. Now I will go to the next element. I can see it's at 3, okay. It's at 3. Now what I can do, I can just go and like I can say both are different. So I will say last element is equal to 3, and I will increment it as a 1, and I will append it to my temp answer. Done. So we are done. So there is nothing in the vector to traverse the next. So this is what we have, like what should we have in our answer. Okay, now how can we put this temp answer to in our in place like input array? So what you can do now, simply now let's try to traverse through the this particular temp. Okay, like for I is equal to n, so where n is equal to temp size. Okay, temp size. Now I will say nums of I equal to temp answer of I. Okay, so I will just repeat this thing. I will so that I can have like I will be overriding all my nums array input array with the temp answer. So at the end I can simply return. So whatever the size of this temporary array, that has to be my answer, right? So I will simply return the n. So n is the temp size. Okay, n is the temp size. Done. So I can say that this could be one solution. So what can be the time complexity of this approach if we followed this? So here I can say that to make this temporary answer, I'm traversing through one time. So I can say that big O of n. So where n will be the nums size. And then I will be traversing to the big O of em. So m will be the size of the temporary answer. Okay, so at max I can say that again it can be big O of n only. So just assume if you are given a vector where every element has been occurred only once, or every element has been occurred only twice. Okay, I am saying every element. So then what could be your answer? Your answer should be the same as your input. Okay, so then you need to traverse like you need to contain all your elements in the temporary answer itself. So I can say that in worst case we need to traverse through big O of n times. So then the overall complexity is going to be big O of 2n. Okay, so can't we do the same in the like a linear time? So if you carefully observe here, we are using an extra space as well, but in problem statement they clearly mention that you need to do the operations in place algorithm. So it is not going to be an efficient algorithm. If you are in an interview, if you tell this particular solution to the interviewer as well, he is not going to be happy. So again he will ask you to optimize the solution. Now think of a solution which runs in an linear time, and you will be modifying all the things in an like input array itself. So how can you traverse? Okay, let me take the same example again, like 1 comma 1 comma 2 comma 2 comma 2 comma 3 comma let's say 4. Okay, now tell me, let's figure out few edge cases. Okay, now tell me if the size of the num, let's say n, if the size of the num is less than 2, it means that it either 0 or 1. Now what should be your answer? Whatever you have in your input, that should be your answer. Like what is the possible solutions? Either let's say you will be having only zeros and ones like in an element, so then either it can be having all zeros or all ones, or 1 0 or 1. That's it. So in all other cases this is valid, this is valid, this is valid. So you can without any fear you can return the index. Okay, whatever values you have, you can return that particular value itself. So here you can say if n less than 2, I will return 2. So sorry, less than, yeah, so less than 3, sorry. even in case of it is going to be 2. Yeah, so this is going to be 2, right? Now what can be your answer for if the values n size is greater than 3? So here I will be taking 2 pointers. Okay, I will be following 2 pointer solution. Okay, let's say I will be taking 2 pointers of one p1 and p2. Okay, p1 and p2. So p1 tells us the pointer where we are exactly, okay, where we are standing exactly, like so until this p1 all my indexes, all my nums array has been in correct position, means the rule was like you need to have at most 2 duplicate elements in a num array, right? So I can say that until this p1 everything is fine. That's what I am assuming for. Okay, so if I'm standing here, I can say that yes, that's an until this second number, I'm pretty much sure that this is sorted out. Okay, all these combinations are good to go. So I will start at here. Okay, by assuming that till here everything is good. Now I will be pointing my p1 here and I will be starting my p2 as well here. Okay, now I will just check. I will just check this p1, okay, like p2 element with the p1 minus 2. So if my p1 is currently standing at index of 2, then if I divide like minus it by 2 minus 2, then it is going to point it to the 0. Now p1 is not equal to the p1, like p2 element, like 2 is not equal to the 1, right? So in that case what I need to do, I need to do something like I need to swap the values. Okay, I need to swap the values. Agree. So what I need to do, I need to make my current num. Okay, wherever I am currently standing. So I am currently standing at a p1. Okay, I should make my p1 as jp2 value, so it is going to be 2, and I should keep on moving to the next element, okay, which is p1 is going to be pointing to next 2. Then you will be incrementing your p2 as well, right? Now again I am standing at p2 here and I need to check with the next 2 elements. So again it is both are not equal. Okay, so I can say replace it with the 2, okay, which is current j value, and just increment your p1. So now p1 is pointing to the 3 and p2 is also pointing to the 3. Okay, now you should see both the values are equal. Okay, sorry, not equal. So again it should be replacing with the 3. Okay, and you will be moving your p1 pointer to the next, p2 pointer to the next. So again it is going to be differ. So yeah, so this is one such element, so here we have taken all the correct sequence, so that's why we are not able to get the exact way how I wanted to demonstrate. So let's take another example where we will be having occurrences more than 2 times. Okay, then maybe should be okay, 1 1 1 2 2 2. Okay, this is going to make sense. So 0 1 2 3 4 5. So again we are starting p1 equal to 2 and p2 is equal to p1. Okay, so on that note I can say that p1 is pointing here and p2 is also pointing here. Now I will be always checking p1 minus 2. Okay, so not equal to p2 value. Now so p1 minus 2 is going to be 1 and p2 value is going to be again 1. So if it is both are equal, I won't say anything. Just move on to the next element, p2. Okay, because as I said, until my p1, I am assuming that everything is in correct order. Okay, correct order. So if I am moving my p1 to here, I need to make sure that until here everything is correct order. So if now I'm not moving that particular p1 here, because here one is not in correct order. Okay, we should replace it with some other value, right? So that's why I'm moving my p2 only. Now I will just cross check with this 2 and 1. Now both are not equal, so now what I will do, I will replace my p1 element with the p2. So p2 is currently 2 and p1 is 1, so I will override it with the 2. Okay, then I will move my p1, and here I'm done with this, so I will go to p2 here. Done. Hope you got it. Now again both so my p1 is pointing here, and so here if I go -2, then it would be 1. So 1 not equal to 2. Yes, it is not equal to 2. Then what do I need to do? I need to replace it with 2. Then I need to move my pointer here, right? Now again I need to go to the next element. Now so I am currently standing here, right? So now what is the p1 minus 2? It's again 2. So 2 equal to 2, so I won't do anything. Okay, I won't do anything. So I will just move on my p2 pointer, so I can see that there is no elements. So here I will stop editing. Now until what element all my things are in how I expected, how I wanted. So I can say that until this thing, until p1. So if I return p1, then my job is done, right? So this is what we are expecting, and the time complexity here as well, we are iterating for only one. Okay, then it is going to be big O of n, okay, at max. So how can we write the code? So we can just write something like int n equal to nums of size. Okay, then we can just check if n less than 3, just return n. Okay, or yeah, just return n. And if like for all the things, like you will be taking 2 pointers, like a p1 equal to starting from 2, then you will be iterating through I is equal to p2 equal to p1 to n. Okay, where n is your size. Then you are just checking if nums of p1 minus 2 not equal to nums of p2. So if this is the case, what you need to do, you need to update your p1 value with the p2 value. Then you need to increment your p1 value. Done. So at the end, you can just simply return p1. Your job is done. Okay. So the time complexity of this approach is going to be big O of n. And if you can clearly see, we are not using any extra space here as well. Okay. Now let's go and write the code for this approach. First, n equal to nums dot size, and if n less than 3, we can simply return n. And for all other things, we need 2 pointers. We will be starting p1 at the second index by assuming that first 2 elements are, we are not caring about if the size is 2, so we are not, we will be starting at the index 2. So then we will be iterating over the loop, like in p2 equal to p1, then p2 less than n, and p2 plus plus. Okay, and if we say if p1 of like nums of p1 minus 2 not equal to nums of p2, okay, then what we need to do, we need to update our p1 value, and need to increment our p1 pointer. at the end we just need to return p1 pointer. Okay, so let's execute this. So we got it. Now let's try to yeah, accept it. And if you can see, it's zero random, like faster than 100%. Oh, oops. Yeah. So yeah, I have already submitted this particular solution, but yeah, you can see that it might be 8 milliseconds. Yeah, so it's sometimes okay. So don't rely on these timings. Okay. So yep, that's all for this problem. Let's solve another problem in the February daily challenge. Okay. So the problem statement will be given something like this. You were given two strings named S and a T. Okay. Then you will be given S and T, and string T is generated by randomly shuffling the string S. Okay, and then add one or more letters at a random position. Okay, return the letter that was added to the T. Okay, since they are specifically saying that it's an sorry. Okay, since they are specifically mentioning that it's a letter, so it is going to be one character. Even the return type was character only. Cool. And so the sample cases here were ABCD were is the S, and ABCDE, okay, is the T, and the changing the change like the character that was added to the T is E, right, extra, so we'll return that E. So okay, and in the second example they were given empty string. Okay, and then a y here. Okay, here the difference is y, right? So that is the thing that you need to return. So the constraints for the length of s is 1,000. So here we can say that only the length of t is going to differ by +1 of the length of s, because only one character is getting added at each time. So this is how the problem statement has given. Okay, so now I highly recommend you guys to pause the video for a while, come up with an a brute force approach. Okay, so what you can do, so I can say that, okay, at brute force, okay, think in perspective of very brute force approach. Okay, if you are in an interview, what you can do, so just iterate over this t of elements, okay, t of characters, and then check whether each character is there in yes or not, in yes or not. If the any of the character is not there in s, what does it mean? It means that that is the character which is the difference, like which is added to the t, right? So you can simply return that character. But now the complexity of this particular approach is going to be length of t into a length of s. Okay, so at max you can take a big O of n square, where n is the size of length of the s or a t. Only one character is getting changed. Okay, so at max we can consider it as a big O of n square. Now the very after searching this particular solution in an interview, so your interview will ask you to optimize it further. Okay, optimize it further. Like you might be wondering, so the length of the string is only 1,000, so this n square solution will get accepted. Then why do I need to submit another, like why do I need to optimize the further? So like LeetCode is an interview preparation platform. Okay, it's not an like CP platform, it's an interview preparation platform. So optimized solution is a way more important than AC. Okay, optimized solution is way more important than AC, means accepted. Okay, so you need to you need to try at max to optimize the solution further. That's it. Okay, so it's an interview preparation. So the main intuition of a lead code is to provide an interview experience. Okay, so if you are in an interview, interviewer expects you to come up with an optimized approach, right? That's how it will work. Okay, now what's next? So you can come up with an nlog n solution as well. Okay, you can do simply you can maintain an hash. Okay, you can maintain a hash, and then you can like where you will be storing the frequency of each character, and then cross check. Okay, so whatever the key like character is getting differ, you will get to know. Okay, so at max in that particular thing, you will be at worst case you will be going in log in time. Okay, and so you can further optimize this login as well. Okay, but you might think that hash map takes a constant time now, then why login? So in sometimes in worst cases it will go in login times. Okay, that's why, so to be on safe side, you need to mention that a login. Okay, so you can further rectify this thing to the big O of n by using the count arrays. Since the question is based upon strings which is having characters, we know that a truth characters are only 26. Okay, you can easily map them into the array or vector, and you can maintain the frequency, right? So after maintaining the frequency, what you can do, you can just cross check. Okay, let's say for this a frequency of a is going to be 1, b is going to be 1, c is going to be 1, d is going to be 1. For the s, okay, like count array of s. And what will be the count array of a, like t? So for a it will be 1, for b it will be 1, for c it will be 1, for d it will be 1, and for e it will be 1. Okay, but in case of count of s, e will be 0, like all other elements will be 0, right? So now what you can do, you can simply traverse through this particular list. So it is again going to be I is equal to 0 to 26, right? So that is the size of your array, and then you can check each index, okay, whether both were equal or not. So whenever you have seen both were not equal, you can say that is the element that got occurred at an extra time in NT. Okay, so for this I can say that complexity of this thing would be like so big O of n plus big O of n to maintain an count array, then a constant time of a big O of 26 to check, okay, in the arrays, and then space complexity is again going to be big O of 26 plus big O of 26. Okay, now further you can optimize. Okay, you can remove the one extra space here. Okay, you can remove this as well. So how can you remove this now? So you are maintaining the count as, okay, so after maintaining count as, go to the count, or you can do something. Okay, first let's maintain the count array of t. Okay, you will get this, and then go to, and traverse through the string s. Okay, and just do the minus. Okay, here it will get minus and it will become 0, and it will become 1 minus 1 0, 1 minus 1 0, 1 minus 1 0, and this except this guys everything will be 0. So now you can traverse through this particular count array, and you can just tell that yes, I have a like so whenever you have seen the index is not equal to 0, then you can return that particular index. Okay, so that will be your character, extra character that has been occurred in the t. Okay, so here the complexity is going to be big O of n to maintain the count of t, then it will be big O of n again for count of s, like to traverse through the string s, then it would be big O of 26. Okay, and then you will be requiring big O of 26 constant memory. okay, to maintain the counter of t. Okay, so again interviewer will be not happy with your solution. Okay, so he will ask you to compute the whole thing in single iteration. Okay, means in single for loop. Now you might be wondering like how can I do that? Okay, so if you if you can so if you have already solved like finding an one time occurred element in an let's say, so you will be given an array where each element, okay, where each element occurred twice, okay, occurred twice except one element. Okay, now how can you do that? It's very simple, right? It's very simple. So if you know what is a bit manipulations, you might heard about the term called XOR. Okay, so what does this XOR will do? Okay, let's say if you are given an array something like this, okay, like 1 comma 2 comma 3 comma 1 comma 2 comma 3 comma 4. So if you do XOR of all these elements, so this one and this one will get cancelled, this two and this two will get cancelled, this three and this three will get cancelled. At the end you will get this 4 alone, because they have clearly stated that each element occurred twice except one element. So the XOR property will give you if same element has been repeated twice. Okay, if you do XOR of those elements, then you will get a 0. Okay, and XOR of 0 with anything gives you anything only. Okay, so this is the intuition behind this particular algorithm. So can you relate this particular logic to this problem? Yes, I can say that. Now let's say, so here every element has been acquired twice except E. Yes, now all this ABCD will get cancelled, all this ABCD will get cancelled except this E. So that is what we are looking for. Done. So here the same, right? So it's a nothing. Okay, nothing XOR Y is going to be XOR Y, like Y. Okay, so this is the intuition behind this particular algorithm. Now how can you write a code for this? So you can write something like okay, okay, let's find first answer equal to, so in C++ or C, both character and integer works in same manner, so that's why I have taken this. And S, and then to answer XOR. Okay, then you can just do the int it of t. Okay, and here answer equal to answer XOR it. Okay, at the end what you can do, so just return the answer. So if you run this code, it is saying accepted. Okay, it is saying accepted, and if I go and submit this, it will get accepted. And yeah, so if you observe, still we are iterating over two loops. Okay, so we have two for loops. Can't we do the same in single for loop? Yes, we can do. Okay, how? Let's go. Okay, Now let's say, let me erase all this piece of code. So let's quickly write the ASCII values or something. Don't think of in ASCII values, because if you're watching this video, you will know some basic stuff about all this programming. So what I will do now, like I will keep on adding these S elements to the answer. Okay, so a plus b plus c plus d. Okay, and then I will minus all these t elements. Okay, t characters. So a minus b, then c, then e, then d. Okay, now this a will get cancelled with this a, this b will get cancelled with this c, this c, d, d. Now at last I will get e. So in single way, so here I have used, first I have added all the first string s characters. Here I have minus subtracted all the t characters. But if you observe carefully, so the question stated that there is only one element is greater than s in the t. Okay, so what we can do, we can first traverse through the s element with the size of s, and then we can add all the s elements, and then we can at the same time we can subtract from that as well. Okay, and then after coming out of the loop, what we can do, we can simply minus from the answer. Like let's say, so here for I is equal to 0 to n, where n is equal to s length. Okay, now I will be taking answer, so plus equal to s of I. Now at the same time I am doing answer minus equal to s of I. Okay, so I am done with n elements. Okay, where s elements. Okay, now I will be left with one element in the t. So what I will do, I will just go a s answer minus t of, so here t of the it is going to be n, right? It is going to be n. Now return my answer. That's it, right? That's it. So if you observe carefully, here we are using only one for loop, right? Here we are only using one for loop. So this is the intuition behind this particular approach. Okay, let's simply go on try to finish coding up this particular approach. Okay, now let's say int answer equal to 0. Okay, let me go and define n as well. So int n equal to s dot size. Now plus equal to s of I, so minus equal to t of I. Okay, after coming out of the loop, I will say answer minus equal to t of n, just return the answer. Basically it is we need to minus s of I, and we need to plus t of I, because we know that while discussing the approach, like intuition, we have seen we got minus e, right? So to overcome that problem, like we know that all the ASCII values will be range from 0 to 256 only. So the negative indexes were not increased here. So to overcome that problem, what we can do now, we can just minus s of I, and we can plus t of I. Okay, so that's it. Okay, we are not doing anything apart from what we have discussed. And if I go on click on run, it should accept now. Yes, now if I go and submit it now, yes, so done. So here, like this is the optimized approach for this particular problem, and we have done this problem using one single for loop. Okay, so yeah, let's solve another problem in the February daily challenge. Okay, so the problem name is add digits. Okay, it's an easy level problem, and give the problem statement will be given something like this: given an integer num, okay, repeatedly add all the digits, okay, until result has come only one digit and return it. Okay, cool. So if you are given n is equal to 38, so what you need to do, so at first you will be adding these two digits, then you will be getting 11 as your answer. Then still you have observed, you can observe that the result is not in single digit, so again you will add this thing and you will get a 2. This time you can see that a result is 2, okay, which is in single digit. Okay, so this is how it should work. And let's say if you are given all nines, like a 999, okay, so at first you will add all these nines, then you will get a 45. Okay, and then like if you again it is in 2 digit, then you will add this thing, you will get 9 as your answer. So this is how it should work, right? So now pause the video for a while, okay, think about a solution. Now let's get started. So let's say very first, okay, let's think in perspective of uh, adding all the digits. Okay, adding all the digits, just forget about the single digit number, just come up with an adding up all the digits. Okay, so let's say while num greater than 0, okay, while num greater than 0, then what I will do, I will first extract the last digit. Okay, let's say last digit equal to num mod 10, right? So if I divide that particular number by 10, I will get some remainder as the last number. Okay, now what I need to do, I will maintain something as a sum, okay, is equal to sum plus last digit. Okay, I will just keep on adding all the last digits. Then I will do num equal to num by 10. So since I have already added this 38, I need to remove that 8, right? So if I do 38 by 10, I will get a 3. This is what I want, right? This is what I am looking for. So I am done. Now what I will get at the end of the day, in my sum, I will get 11 as my answer. Now just think, okay, so at this particular statement, after some time it will get 0, right? Okay, your num will get 0, and then just add a check. Okay, if num double equal to 0 and your sum greater than 9, okay, greater than 9. Now what does it mean? What does it mean? So you have added all the digits, okay, but still your sum is greater than 9, means it is not in single digit. So now what you need to do, you need to repeat the same task for the sum. Yes, agrees. Now what you can do, just do num equal to sum. Now again what you need to do, you need to make your sum is equal to 0. Done. So at some point of the time, like again you will start with 11. Okay, now your 11 greater than 0, so last digit is going to be 1 and sum is equal to sum plus last digit. So your currently sum is 0, now it's going to be 1. Okay, now again you will do 11 by 10, you will get 1. Okay, so num not equal to 0, so again you will go back and still it is okay, then it will enter into this particular loop, then last digit will become 1, then in your sum you will be having currently 1, so if you add last digit it is going to be 2. Now you will do num is equal to num by 10, it will be 0 now. So here num is equal to 0, yes, it's a true. Now sum greater than 9, no, your sum is 2. Okay, so you won't enter into this piece of code, so you will directly come here, so your num is equal to 0. so which is not greater than 0, right? So you will come out of the loop and you will return sum. So you will get your answer, right? You will get your answer. So let's go and try to code this particular approach. Okay, so at what I chill. Okay, so at first I am saying int sum equal to 0, then I am entering into the while 0. What I will be doing, I will be extracting the last digit. Okay, last digit equal to num 10. Then you will be adding the value to the sum. Again, you will be storing that result in the sum itself. Now you need to divide your num by 10, and then you need to check if your num became 0 and a sum greater than 9. It means that it is not a single digit value. Then what you need to do, then you need to repeat the same task for sum as well. So you will make you will store a sum in the num, and then you will make sum is equal to 0. Okay, after coming out of the loop you will simply return sum, right? So if I execute this, so it is get accepted, and if I run this piece of code, yes, it got successed and faster than 100% of C++ code. So usually don't believe in this okay, accuracy of LeetCode. Okay, it might change as per your submissions. Okay, and so is this the perfect solution? Okay, is this the perfect solution? No. Okay, so though it got accepted, so here you can say follow-up question. So could you do it in without using loop or recursion? Means they are asking us to do in constant runtime. Okay, so now keep on your toys. Okay, now how can you think? Okay, so think. Okay, pause the video for a while and think. Now let's see. So let me erase this code. So basically in mathematics, okay, while preparing for JE or BITS exams, you might learn this divisibility rule. Okay, so like if you need to check whether a given number is divisible of 9 or not, so then how can you check? So whatever the digits you have, like sum of all digits in number is divisible by 9, then we can say that num is also divisible by 9. Okay, so this is the general formula. Okay, so now think. So just try to relate this particular problem to this particular formula. Okay, now you can come up with a solution, I guess, mostly. So now just tell me, if I have given num is equal to 0, then what will be your output? It should be 0. If I have given your num equal to 9, what will be your output? It should be 0. Now if I have given my num is equal to something like 81, now tell me what will be your answer. Your answer should be 9. So just check whether this particular number is divisible of 9. So why do we need to check? Okay, just check now. So how can we do that? So if sum of all digits is 9, so if this particular 9 is divisible of 9, then this number is going to be divisible of 9. So I will say it will return remainder equal to 0. So if we got remainder as equal to 0, then we can say that num is an perfectly divisible. So on this note, how can we say, like, let me take another example. Okay, so where a num is equal to 38. Okay, so what will be the sum of this? It will be 11. So if I find the remainder, what will be the remainder here? 2. 2. It means that to make this particular number divisible by 2, I need to minus it with the 2. So if I do minus, it will be 36. So 36 is going to be 9 divisible. So what is the thing? What is the thing? So I can say that remainder of 9 is always, okay, whenever I am finding a remainder of any number by and within 9, I can get only the numbers which starts from 0 until 9. So can I say, if I relate any number to the ninth module, ninth remainder, ninth table, so my job is done. Yes, so that is what I will be getting. Okay, so that is the intuition behind this particular algorithm. Okay, so here we can say, we can compute this thing in a constant time. How can we? Let's go and see. So we know few facts that whenever our num is equal to 0, we can simply say return 0. And if else, if our num mod 9 is equal to 0, num mod 9 is equal to 0, again it is going to be return 9, right? Return 9. So like if you are given a num is equal to 81, okay, 81, you will be getting your answer as a 9. Okay, so 81 is a model of like divisible of 9, so you should return 9. So if you take num is equal to 36, again it is going to be 9. If you take 27, again it is going to be 9. So all the factors, or like all the multiplication table of 9 will give you the sum of 9 itself. Okay, so in all other cases, just return num mod 9. That's it. Okay, so if I run this code, it accepted, and if I go and submit it, this I can accept it. Okay, so here you can see, so it is a constant time, it runs in a constant time, but again still it took 4 seconds. Okay, but earlier we have used recursion like a loop, but it still took a 0 millisecond. Okay, so but when I executed these things in reverse order, I got it the runtime time in reverse order. Okay, so for this particular solution I got 0, and for a loop I got 4 seconds. Okay, so don't believe in this time, okay, runtime. Okay, it might be keep on changing. Like if you submit the same code multiple times, your runtime will get changed. Okay, so don't believe in that. Okay, keep on practicing. That's it. Let's have another problem in February daily late challenge. Okay, so this time the problem name is k difference pairs in an array. Okay, so let's try to see what is the question here. So given an array of integers, okay, num, and an integer k, okay, you will be given an vector or integer, or sorry, array with the name of nums, and you will be given an k as well. Return the number of unique k difference pairs in an array. Okay, makes sense. So a k difference pair is an integer, okay, where the following are true: I not equal to j, and nums. Okay, so this is what you need to do. So a num of I minus num of j, that should be equal to the k difference. Okay, and notice that value. Okay, so this is going to be mod. So yeah, even if you get an a minus difference as well, it should be equal to the plus. So that is what they means. And so they have given one sample. Okay, for this you will be getting answer as a 2. So the pairs are 1 comma 3 and 3 comma 5. So if you observe here, so you will be having a 2 pairs with the same, like 1 comma 3 and 1 comma 3, but they have considered only once because they have already mentioned that unique pairs, they need unique pairs. Okay, so here both are same, right? So they are not interested in that. Okay, they need only unique one. So now I hope you have understood the problem. Please pause the video for a while. Okay, then think of a solution. So think of a brute force solution. Okay, need not to do much, just think of a brute force solution. So now let's get started. So we will be having only 2 pointers, right? I and j. We will be having only 2 pointers, I and j. So we can simply run an two for loops, and then we can do an minus, and can check simply if the difference is equal to the k, then we can do count plus plus. But here you need to handle the set function like unique k difference as well. So for that you can simply create a set, okay, of pair, then you can achieve that. Okay, it's not a big deal though, but the thing that you need to identify complexity. So if you run two loops, then it is going to be big O of n into n, so n square, and again you will be maintaining an set. So like you're coming to space complexity for set, let's think at most you will be required big O of n memory at least, right? So yeah, of course set operations is going to be big O of 1. So this is the overall complexity. If you go and submit it, I guess you will get an TLE. Let me just check the constraints. Yeah, it's a big O of 4. So yeah, I guess I hope it works sometimes. Okay, but if you are doing a lot of maths computations over there, it won't. Okay, so now if you are in an interview, if you tell that particular two for loop approach, then your interviewer will be not at all interested in that, so he will ask you to optimize it further. Okay, so optimize it further means you might think come up and another solution based upon sorting which we do for finding like n of place num of j which is equal to k. So we do sorting, two pointers technique, right? So we can do the same here. Okay, like first sort the array, then do two pointer approach, and you will be able to figure out. But like you might think sorting will be taking n log n time, and two pointer will take n log n time. But I won't suggest to tell this approach if you are in an interview, because it is going to kill a lot of time. So here there will be a lot of edge cases to handle. First case is going to be duplicate checks. Okay, so you need to handle duplicates, you will be having a separate while loop to eliminate all the duplicates, and you need to handle few other cases as well. So it is going to kill a lot of time, and again the complexity is going to be n log n, so your interviewer will ask you to optimize it further as well. So in that case, I recommend you guys to better jump into the if you have another solution which takes n time, then I recommend you guys to directly jump onto that particular solution after giving big O of n square solution. So it will save you a lot of time. So since it's a medium level question, so there were if you are in a product based company interviews like Amazon kind of stuff, then there might be very high level of chances. So you will be getting this question in an as your first question. So don't waste a lot of time in the first question. So you just like keep some good amount of time for your second question as well, because second question is going to be a little tougher than first question, so it requires more time. So I highly recommend you guys to have some time for that as well. Okay, so enough. So now let's go and discuss another solution which runs in an constant time, like linear time. So yep, so here we will be having let's take this particular vector. So 3 1 4 5. So here we will be maintaining our frequency. using map, like unordered map or ordered map. So I recommend here order doesn't matter, so you maintain unordered map, so it is going to kill our some save our some time complexity. So now just go and store all the frequency. If you store that, it is going to be 3 1 and 2 1 2 times, 4 1 times, and 5 1 times. Okay, this is the frequency of your now as of now. Now what you need to do, you need to just iterate over through this map. Okay, iterate over through this map and just find an like mod. So here we will be doing like we required a minus b double equal to k, so it will be a turn out to be a equal to k plus b as well. So just find for this a, okay, in the map, and if you find that a in the map, just add answer plus 1. Okay, then if you haven't found the a in your map, then it means that there is no pair exist. Okay, just move on. So here again, if you find the particular element in the map, again you need to check these cases as well, like where both the elements which you are searching for and which you found for, like let's say if I have given my k is equal to 6 and I'm searching for 3. Okay, and if I do 6 minus b, then I will get a 3 as well. Now I will be searching for 3. Okay, if I search for 3, I will get a 3. But here one thing that you need to identify here is we are both are pointing to the same 3. Okay, which we are searching for and which we are finding an a pair for. So in that case, how can you handle that pair? So just check, okay, like the key double equal to the element which you are searching for. Okay, if that is the case, and just check the frequency. Okay, like there might be high chances, like if you have another element called 3, so in that case you should consider that pair, right? So just check. Okay, if like map of a greater than 1. Okay, then you can simply say add plus plus, done. And then else you can just add answer plus plus as well. Okay, so it should work. Okay, it should work. Now how can we do this? Okay, what is the time complexity here? So to maintain hash, we will be iterating over big O of n times, plus then again we are iterating over the map. So at max in map, it might contain big O of n elements, and then for finding in map it is going to take big O of 1 in best case. Yes, so if you consider the overall time complexity, it is going to be big O of 2n. So if you consider upper bound, it is going to be n, right? And coming to the space complexity, we are using a map. So at max it takes n elements. Okay, so it should be fine. Okay, if you are in an interview, if you tell this approach, I think it's okay. Interviewer will accept that, and then you can happily move on to the next problem. So now let's go quickly code this up. Let me do. Let's say at first we required a size here. Then so yeah, we need to iterate over the elements like in nums. Okay, and we need to create another map here, another map of int comma int mp, and mp of a num. So now I have done with maintaining an hash. Now what do I need to do? I need to iterate over the map, and I just need to check whether the particular element which I'm searching for is there or not. Okay, so I will maintain an like a count equal to 0. Now I will iterate over the all the map elements, and now I need to check and pair. Okay, pair equal to k plus it dot first. Okay, and if I will check whether I can find that pair in my map. Okay, so mp dot end. So if I find the pair, then what does it mean? So yes, it exists, but we need to handle these cases as well. So I will just add an if. Okay, the element which I'm searching for and the pair which I'm searching for both are equal, like equal. Then what I need to do, then I need to check the frequency of that particular element, and if it is equal greater than 1, yes, okay, you can increase the count. Okay, and then else I can say then else if as well. Okay, so if the element which I'm searching for and pair which I'm searching for both are not equal, or not equal, I can say just count it. Okay, so at the end it should return a count. Works. Yeah, accepted, and then we'll submit it. Let's see what happens. Yeah, I submitted in one go earlier. Yeah, after seeing problem, you will get it. Okay, so this is very kind of basic problem. If you done a 10 to 12 problems on hashing, and if you submit that to some problem, then you can solve this particular problem very easily. That's why, yeah, I come up with 10 solution very quickly. First thing, it's yeah, it depends upon constraints as well. So since constraints were big of 10 power 4, so it's very easy to come to an solution. Okay, so unlike if the length is going to be big of 10 power n or something like that, then it requires to optimize it further, like you can't use space much kind of stuff, but it's very low. Usually in LeetCode, this is what happens. Okay, constraints might not too long, but I highly recommend you guys to practice further as well. Like if your solution has been submitted, then don't stop. Okay, just go to the discussion forum and just check out the there is a solution if that is better than yours, like a better time complexity, then try to learn that particular algorithm as well, because in an interview time complexity matters a lot. Okay, so yeah, so let's solve another problem in February daily challenge. Okay, so the problem name is a subarray sum equal to the k. Okay, let's go through. So this is a medium level question, and it has very good problem which has 10k plus likes. So yeah, it's very rare that you can see 10k plus likes in LeetCode. Okay, so you will be given an array of integers and num. Okay, and an integer k. Okay, return the total number of continuous subarrays whose sum equal to the n. Okay, so you will be given an array or vector, and you will be given an k. Now you need to figure out how many sub arrays, okay, are there whose sum equal to the k. Okay, now let's see. Okay, so you will be given this array and the k equal to 2. So if you observe, I can consider this one as my one subarray whose sum is equal to 2, and I can consider this as my subarray whose sum equal to 2 again. So I can say that at max I have two subarrays whose sum is equal to 2. Now you might wondering, yes bro, I can consider this as well, right? So this one, so it is going to be 2, but they have clearly mentioned that continuous subarray, okay, whose indexes must be in sequence. Okay, not in I will pick up this random guy and I will add this and I will get a 2. Okay, this is not something like that. So it should be in continuous subarray. So now please pause the video for a while. Okay, think. Okay, just come up with a brute force approach that you can figure out. Okay, so if you are watching this video till here, then I might assume that you have some good amount of knowledge on DS. Okay, so if not, so don't worry, you can find plenty of videos right here in this particular channel. Okay, all you need to do is just go through another video, like just go to the playlist. There you can find a lot of plenty of videos on data structure of right from the basic and right from to the advanced levels. Okay, so I highly recommend you guys to go through that once. Now, okay, so now let's get started. Okay, let's discuss these particular approaches. So yeah. Okay, so let's take an array. Okay, so who's 1 2 3, and if I have given my k equal to 3, then how many subarrays are there in total? So I can consider this one subarray as my subarray and whose sum is 3. Yes, 1. Then I can alone this consider this 3 as my one subarray, right? So a subarray, it can be a null as well, one element, two elements, okay, three elements, okay, but it should be in the sequence. That's it. Okay, now let's come to this particular problem. How you gonna solve this? Just think in perspective of brute force. So if I think in perspective of brute force, then it should be like generating all the subarrays. Okay, generating all the subarrays and finding and sum of each subarray and checking whether a sum is equal to k or not. Okay, so I can say that generating subarrays will take big O of n square. So if you are try to optimize that further, and again for each subarray that you have generated over here, you need to find the sum by traversing at the once again. So it is going to be at max big O of n cube. Okay, so you don't require any space, so it would be big O of 1 only. So this is the very brute force approach that you can come up with. Okay, and again, so you know what interview expects you to do. So then the first thing that he can ask you is try to optimize it. How you gonna optimize this? Okay, so if you carefully observe, you can eliminate this particular n. How? So you can keep track of sum while in the second loop itself. Okay, after generating that, just come up, check with a key. Okay, then you are able to figure it out. So then this time still time complexity is going to be big O of n for generating all the subarrays, but you don't require this big O of n to sum up all the numbers, right? So you can say this time your complexity is going to be big O of n, and again space complexity is going to be constant. Okay, so again your interviewer will ask you to optimize it further. Now here comes the picture, okay, which is going to be optimal. So I won't say optimal again. Okay, so let's say optimal 1. Okay, optimal 1. So here the here the thing here is, okay, we'll discuss that. So let's say you have an array which is 1 2 3 4 and 5. Okay, now your k is 9. Now how you gonna find how many subarrays are exist with the k is equal to 9? So just just try to keep just try to solve this and keep the count in your mind. Okay, so I will tell you how to do this. Now first I will be computing the prefix count, prefix sum. So why I am doing this I will tell you later, but as of now just follow me. So for here it is 1, for here it is 3, for here 6, 10, 15. Now we have generated prefix sum. Now let's say I want to find the k is equal to 9. So now let's say we'll just check whether this particular element equal to k or not. I find that no, it is not. Okay, then I will move on. Then I will check this one is k or not. No, I will go here. This here I will again check whether it's a k or not. No, again it's not a k. Now I will come here. Okay, now I will just check. So I won't find like both k and 10 are not equal. So but instead of going to the next element, I will just check. Okay, so if I'm reaching 10 here, if I'm reaching 10 which is a greater than 9, okay, greater than 9, there might be an element, okay, there might be an suitable element where if I divide that element by the 10, sorry, if I subtract that element from the 10, I will get a k. So here in this case it is 1. So it means that the sum till here is 1. Okay, and from here you got 10. Okay, so if you exclude this 1, okay, if you exclude this 1, then the sum you are carrying till here is going to be 9. Can I say that? Okay, let's check this out. Okay, so what you are doing, you are excluding this sum till here. Okay, and you are currently here, and if you add all these numbers, then you are going to get 9, right? Yes, it's a valid one. It's a valid one, right? Now I can say that count plus plus. Okay, so my count is 1 now. Now I will go to the 15. Okay, k is not equal to 9. Okay, now I will do 15 minus 9, means it's a 6. Okay, it's a 6. Now by adding all the numbers till here is I got a 15. Now till adding all the numbers till here I got a 6. Okay, and what I can do, so it is something like this. Okay, let's say the total sum is k. Okay, the total sum is k. Now till now the sum is x. Okay, the sum is x. Now if I wanted to find the sum from this particular point to here, then what can it be? I can say that k minus x, right? K minus x. So the total sum is k and the sum till here is a x. Okay, if I wanted to find sum from here to here, I can say that it's going to be k minus x, right? So I am pretty much sure that it is going to be equal to the k. Okay, if you are standing at that particular point of time. So this is the intuition behind this particular algorithm. So you are just finding all the sum till that particular index, and at current index you are checking whether the sum is equal to 9 or not. Okay, and if it is equal to the k, then you will be just doing count plus plus, and if you find an suitable pair as well, you won't do much thing. Okay, you will just cross check and you will just add up that. Okay, so let's solve another example so that you will get an good knowledge on that. So why? Because this particular problem has an follow-up question of 2. Okay, one is going to be k, what if k equal to 0? Okay, what if k equal to 0? So this has separate question. Okay, like sub array sum, okay, whose value is equal to 0, whose sum equal to 0. So that is another most important question along with this. Okay, so you can solve that as well if you understand this. So if you understand this, how can you solve that? So when just replace, just assume your sum is all like your k is always 0. Okay, then solve that problem as well. So meanwhile, let's solve another problem. Okay, so this time you will be given an 1 3 5 and minus 5. Okay, now let's see. So let's compute the prefix sum. So till now 1 4 9 and again it is going to be 4, right? Now let's say my finding is for k is equal to 4. Okay, now I'll stand here and check it is not equal to the k, and even if I do minus, like 1 minus 4 minus 3, I won't find any value. Now I will go here and I will just check if it is equal to the k. Yes, it is equal to the k. So what does this mean? What does this mean? If it is equal to the k, what does it mean? So means that I have added all the values till here. I have added all the values till here and I got the sum equal to the k. Yes, that is a valid condition as well. So I need to add the count plus 1. Okay, it is going to be only one subarray like that. So I will make my count plus 1. Okay, good. Now I will go here. I will go here and I will check. Okay, so now it is not equal to the 4. Then I will check 9 minus 4. So 9 minus 4 is 5. And if I find an 5 in between, like earlier coming to the 9, it means that, so I have seen 9, I have seen 5 and I have seen 9. So the difference between 5 and 9 is 4. Okay, so if and only if I have added 4 from the 5 to 9, I can get a 9. Okay, so I can assume that it's going to be 9. So I haven't found the 5, so still my count is equal to 1. Now again I will come back here and I will just say if it is equal to the k or not. Yes, it is equal, so I will increment it plus plus, so it is now 2. Okay, and I will just check 4 minus 0 is going to be a 0. Yes, if I found any pair with the sum 0, okay, like any pair with the sum 0 till now, I can say that I can add another point. Okay, now on this note we can say that I hope you have understood. So coming to the time complexity, okay, here the time complexity of prefix sum. So to calculate the prefix sum, first it is going to take big O of n, then we are doing again iterating over the prefix sum, which is going to be big O of n. In that we are doing our operations. So on map, okay, we are considering a map, right, like where we will be storing all our occurrences till now. So the space complexity is going to be big O of n in the worst case. So since unordered map takes big constant time, so then we can say its time complexity is going to be order of n in the upper bound. Okay, and space complexity is going to be big O of n. Okay, so let's go and try to submit this particular solution. So we will be required an a vector to maintain our prefix sum. Okay, let's say then I will traverse through all the elements in an array, and I will just add up all the numbers. Let's say I have an sum equal to 0, and I will add a sum plus equal to it. I will say prefix sum dot up pushback that particular sum. Okay, so I have done my prefix sum. Now I will create an unordered map, which is going to be int of int, then empty. So by default I will put an current k in it. Okay, current k, or if it is as any value in it, then I should consider that as well. Or you can do considering 0 as your key as well. So if you found like k minus 0, it is going to be same value, so you can consider that as well. For now I have considered that. Now you need to go through all the elements in the prefix sum. Now you need to check if the current prefix sum equal to the k. Okay, if it is the case, then you can say count plus plus. Okay, we haven't created the variable called count, so int count equal to the 0. And after that we need to check, so in if we can find the k minus, okay, the sum minus, okay, the sum is it, okay, it minus k. in our map, okay, in our map till now, I can say that just add up that as well, like whatever the combinations you have, you need to add that. So mp of it minus k. Else, so if you are not able to find, you need to put like in all other cases you need to make sure that you have added that element, so just do that. So after coming out of the loop, then you can simply say return count, sum minus k, then yep, it should work now. Let's see. Okay, sorry, we need to put something in, insert our k in our map. Yeah, so k come. So we are off done. So let's solve another February daily challenge, a problem named a permutation in a string. So don't get confused, okay? Don't get decide what is the problem statement after seeing the name. So they are stating that a different problem statement than the name, okay? So you will be given two strings s1 and s2. Return true if s2 contains a permutation of s1. Okay, s2 contains a permutation of s1 or false otherwise. Okay, so in other words, return true if one of s1's permutation is the substring of s2. So a permutation is an let's say if I have given an a b c, okay, so all the sizes, okay, all the size with the same, like if I have same size of any string which contains all these numbers or like all these characters, I can say that as a permutation. So if I write this as a cap, this is this is a permutation of abc. So here the permutation definition is going to be, it should contain all the characters along with the same frequency, okay, along with a same frequency. Then we can call it as a permutation of a given string. So I hope you got the what is a permutation. Now they are stating that they will be giving you an s1, okay, and s2. You need to check whether s1 is a permutation of s2, okay. So just simple that's it, okay. So here always s2 size can be vary from the s1 to any number, okay, a different extent. You need to check whether any of the substring, okay, like here they have given ab as s1 and s2 as ei db a o. So here if you observe, this is a permutation, right? ba, so ab and ba, so the frequency of a is 1, b is 1, a is 1 and b is 1. So we can say that this is a permutation. So s1 is a permutation of s2. So this is how the problem statement has been given. And if you observe the second string, so here we have ab, so you can have ab or a ba in the s2, then you can say that it's a permutation, so you can return true. So here we don't have any substring which has a BA or AB, so that we can return false. So at glance, this is the problem statement given. So please pause the video for a while. Okay, just think about a solution. So I can say that uh, so if we if you guys know what is how to generate a substrings, how to generate substrings, then you can simply generate an substrings with the size of s1. Okay, generate substrings with the size of s1, and then check frequencies are equal. Frequencies are equal. That's it. So this is as simple as that. Now like what will be the time complexity and space complexity of if you follow this? It's a very brute force approach, I can say that. So what will be the time and space complexity of this approach? So for generating all the substrings with the given s1 size, you should run in two for loops. Okay, your outer for loop helps you to pick up one guy, like stand at one element, and then inner for loop helps you to iterate over the s1 size of the substrings. Okay, so I can say that at max you will be iterating to s1 into s1, sorry, s2 into s1. And if you consider this is the best case, and so first way of generating the substrings is it is going to take three for loops. So s1 into s1, sorry, s2 into s1 into again with the size of s1. Okay, so this might happen, but just consider, I'm considering this is the case. And then you need to maintain an hash map where you will be storing all your frequencies. Okay, to store your frequencies, and then you need to iterate over the hash map and then check. So I can say that at in worst case it is going to take s1 into s2 times. Okay, and which is not an efficient approach. Here you are using two hash maps as well, one for s1 and one for s2. Okay, so of course your interviewer is not happy with that particular solution, so immediately he will ask you to optimize it further. Okay, so whenever there is such kind of problems with the strings, okay, like which requires an frequency, okay, string frequencies, then you can always use an integer or vector to store frequencies, because we all know that there will be only 26 characters, okay, which you need to keep maintaining. And at max if you have considered you will be given both upper and lower cases, then you can consider 52. Okay, 52. And okay, you can even if you can consider all the ASCII values, it should not be greater than 256. Okay, again it's a constant only, right? It's not depend upon the like if you are given your n is equal to 10 power 4, again it is going to be 256. Okay, it's going to be in constant. And we know the fact called to access the integer or a vector elements, we will be required a constant time. Okay, so with that approach you can reduce your complexity a bit more as well. Okay, and this is the one fact that everyone should know, okay, while solving string based frequency problems. And yeah, we will be using this in our problem. And again whenever there is a problems, okay, where you will be maintaining sequence or substring kind of stuff. Okay, like where you will be containing, like where you will be maintaining all the elements, okay, some set of elements which are in some sequence, okay, like one after one, then you can consider an approach called a window. Okay, window approach, like so where you will be considering each window at a time, and then you will be solving that problem. So let's see, okay, how that particular window is going to help us to solve this problem. Okay, so let's quickly erase, yeah. So now let's say you will be given an S1 equal to AB and S2 equal to EI, DB, AB, AOO. Okay, so this is the substring, sorry, S2 and S1, and how you are going to approach this particular problem is now. So here you know that you required only the substring with the size of 2, right, size of S1. So then what is the need of generating all other subsets which are greater than that particular size? There is no need as well. So that is our first thing, like no need of generating a substrings greater than S1 size. So this is the first fact that you need to know. And second fact, a substrings will contain a sequence of characters, okay, or a numbers as well. Okay, like this particular technique will work for okay, a sliding window. Yeah, sliding window will technique will work for uh, a string, sorry, array based. Okay, so like integer array based problems as well. So yeah, it's a very good technique that everyone should learn. I can say that in sometimes this sliding window technique will help you to solve the problems in big O of n time. Okay, where a sequence is matters, your order is matters. Okay, so in that case I just check whether you can apply sliding window technique or not. So here the sequence is matters, and no need of generating all the characters which are more than that as well. So that is a one fact that we can decide upon the approach called a sliding window. So what is the exactly sliding window will do here? Okay, so let's say, okay, let me erase this up. So okay, so here the S2 is EI, D, B, A, B, A, O, O. Okay, now AB is A, B. Okay, S1 and S2. So we need a substring with the length of this two itself, right? So first what I will do now, I will consider a window, this particular window, and I will just check whether this particular window, like a frequency of two windows are same or not. Okay, if it is same, what does it mean? It means that both are permutations. Yes. So if it is not, what do I need to do? I need to go to the next two substring size. So in that case, I will go to ID. So if you observe, while moving on, I need to eliminate this particular frequency as well. Okay, so let's come to that later. So as of now, just see. Okay, so this is how first I have considered EI, then I have considered ID, then I have considered DB, then I will be considering BA. So here I am generating all the substrings with the size of 2, right? Will just moving my window each time, that's it. Okay, and while moving on, I will be just leaving one character and just adding one character. Okay, leaving one character, adding one character, that's it. Okay, so leaving, you guys know, so every time I'm leaving I will be starting from the first index 0, then I am moving on to the next leaving guys, like first 0 then 1 kind of stuff. So you can easily keep track of your leaving index, and you can turn out in a loop. Okay, then you can add upon the guys which you need to add, that's it. Okay, it should work. Okay, And now here comes the problem, how to solve this particular problem. Okay, so let's take an example of A, B, C, D, E, F. Okay, and my thing here is E, D. Okay, so this is S1 and this is S2. So at first I will consider a window at first. Okay, I will consider a window with the size of S1. So before that I will be creating a frequency vector where I will be storing all my frequencies of characters. Okay, so here let's say frequencies of S1 and frequencies of S2. Okay, so here in frequency of S1 I'm pretty much sure that every time my frequency will not going to change. Okay, so here I have E is 1 and D is 1, so I'm pretty much sure that my S1 frequency is not going to change. Okay, and only my S2 frequency is going to change based upon the window which I am storing. So currently first I will just check these guys. Okay, first I will take first window. Okay, then I will calculate the frequency. So here the frequency here is A1 and B1. Now after getting, whenever I get a window size of which I am looking for, then I will just check. Okay, check the frequency. So if both the frequencies are same, okay, then I will return true. So if, what does it mean if these both the sequences or frequencies are same? What does it mean? It means that both are permutation. Yes, so I can simply say return true. Okay, if not, okay, there might be another window which might take us to the exact frequency which I am looking for. Okay, so here I need to leave this A and I need to add this C. Okay, how can I do that? So I will keep a variable called leave. Okay, then at first I will be considering this, and every time I will be doing just so whenever I am leaving this I need to erase that particular frequency as well. Okay, so I will remove the B. Okay, A, and then I will add the frequency of the element which I am adding, so it is going to be C1. Okay, now I got the another window with the size of 2. Now I will just check both are equal. No, not equal. So it means that we need to erase that. So we need to erase the B now. Okay, the last, okay, left side window. So erase B. Okay, add the D. Add the D. So D1. Now I will go and check both are equal or not. So again both are not equal. So now again I will erase this up, the leftmost bit and in character in a window. So C going. Then I will add the next element in a window. So it is going to be D and sorry E. So now I will check that both the frequencies are same. So E1 D1 E1 D1. Yes. So I can say that I found a permutation of a S1. So I will return true. Return true. Done. So this is how we got this particular solution, right? So what does it mean if we went on till here and if we are not able to find the same frequency? It means that return false, because we haven't found the guy like which gives us the same permutation. Okay, same frequency. So at the end I will return false. Okay, if you want me to summarize, how can we do that? Okay, so first find the frequency of S1 and S2 with the size of S1. Okay, then check both are equal. If S, then just return true here itself. Okay, need not to bother much. If not, then you can enter into a loop where you will be starting from S1 index and traversing to S2 dot size, and each time check both are same or not. if not same, like check. Then if it is true, then return true. Otherwise you can come back, and you need to eliminate, like you need to remove the last index, like a living index frequency. So you can say if your vector name is something like frequency, so if your hash name is something like hash of s2, then you need to leave something like hash of leave minus minus, and then you need to increase your leave so to the next index. Then you need to add the current index, so I plus plus. Okay, and this is how you guys do the stuff. Okay, now how does it work? So let's try to go and write the like try to convert this into the programming logic. Then we'll try to discuss the time complexity and space complexity of this particular approach. So at first, as I said, we required an two vectors. Okay, we require and two vectors. And, it is going to be hash one. Okay, let's consider hash one and hash two. Okay, done. Then we need to figure out the sizes of both. So s1 dot size, s2 dot size. Okay, and we can just check an thing here called the sizes. Okay, so if by any chance the size of n is greater than m, it means that our s1 is like contains an more characters than m2, okay, s2, then it means that at any chance we are not going to have an a permutation with the same size, right? So we can just check that and we can return our false here. Okay, and then in all other cases we need to maintain our hash, then we need to do our task. So at first, what is the size of the window that we need to maintain a hash? You can say that it's an m, right? So hash one of one, then oh sorry, hash one of yeah, s1 of I minus a plus plus. So why do we do minus a? So we will get an exact letter. Okay, and then we need to maintain an hash 2 size as well, like string 2 size as well. So h2 of I plus plus. Now what we need to do? Now we need to just check. Okay, so we can do that in loop as well. Okay, so now we have an both the hash of first size window. Then we need to start our next window, which is from size of n, and then it is we need to check till travels till s2. Then we can just check if is permutation, so where we will be passing our hash 1 and hash 2. Okay, and if it is a true, what we can do, if it is a true, we can simply return true. And in all other cases, what we need to do, we need to maintain our index called a leave index. Okay, so at first we will be leaving our 0th index, so we are maintaining that. And s2 of leave index minus a, and it is going to be minus minus. Okay, then we need to add the current value to our hash, right? So sorry, it's hash 2. Yeah, hash 2. So s1 s2 of I minus minus a plus plus. Okay, then we just like that. And so let's go and write the code for the is permutation. So bool a vector of in dash 1, then a vector of in hash 2. Okay, then we need to iterate over the two loops. Okay, sorry, is going to be size of 26 only. So yeah, 26 comma now we need to iterate over the 26 characters, like 26 size, and we need to check all the indexes are same or not. Okay, so I is equal to 0 to I less than 26 I plus plus. So if we found any of the thing is index is not equal. So what does it mean? It means that both the frequencies are same. So in that case we can just return false. So if we pass through this particular loop, it means that both all the frequencies are same. So we can simply return true over there. Now we are not checking the last window. Okay, we need to check that as well. So is hash 1 hash 2. So if it is same, we can just return a true over here. Otherwise, just return a false. That's it. Okay. Now let's try to submit this up. Yeah. Okay. So hash is not okay. Name, yeah, 2 is missed. Yes, it is a false. It is saying the false. So why it is false? Yes, please. And place. Both are same. True. Okay. So we are not increasing our leave index. Let's discuss another problem in a February diary challenge. Okay, so the problem name is subsets. So you will be given an integer array, okay, which are very unique, means the elements which are present in an array are unique. So return all possible subsets. So in bracket, the subsets are also called as a power set. Okay, and the solution set must not contain duplicates. Okay, return the solution in any order. So the question is a very straightforward. Okay, they will be giving you an array, and you need to return the subsets which are not duplicate. Let's come to this point, must not contain duplicate. So when can we get a duplicate subsets? So if and only if I can say that if there are any duplicate values in the array, like input array. So let's say if I have given an array like this, and if I have asked to submit generate all the subsets, then it should be like on empty 2 2 and 2 comma 2. So this is the power set of the this particular uh, array or vector. So here you can observe this. So both are not unique, like these are duplicates, right? So I can say that, so whenever we get an duplicate elements in a given array, then only we'll get an duplicate values in the resultant subsets as well. So in our case, we don't need to bother about that, because they clearly mention that we will be getting only unique elements. So it means that we can generate all the subsets which are very unique. Okay, so let's just go through the given examples. Okay, so they have given 1 comma 2 comma 3, and this is the power set for that. Okay, so we'll talk about what is power set in detail. And let's look at the constraints as well. So a num length is 10. Okay, so it's very basic, I guess. So if the like, you need to remember one golden rule. So whenever the given size is like less than 15, means if it is 12 or 14, then your exponential solution will also work. Exponential solution will also work. So what is this exponential solution? So whenever there is a term called exponential, you need to get the topic called recursion. Okay, so basically a recursion wala solutions takes exponential time. So 2 power n, 3 power n, 4 power n, so kind of things. Okay, so I'm saying that this particular question will accept the solution which is in exponential manner as well. So we don't need to bother about the complexity now. You have an write permission till 2 power n. Okay, so now please pause the video for a while and just try to think of a solution, okay, that you can come up with. Meanwhile, let's go and understand what is subset and like what is power set and all. Let me erase this now. Yeah, so subset or power set. So basically subset or power set is an sequence of numbers, means subsequence of numbers, okay, which is always in the increasing manner order. Okay, let's say if you have given 1 comma 2 comma 3, then it will contain 2 power n subsets. So what is this n? So n is going to be size of the nums. So here the size is 3. So the value of 2 power n is going to be 8. So it means that you will be having 8 subsets for this particular input. So what are they? So it will first contain a empty one, then it will contain the 1, then 2, then 3, then 1 comma 2, 2 comma 3, 1 comma 3, and yeah, and it will contain 1 comma 2 comma 3. So these are all the subsets which you need to generate if you are given this particular input. So how can we generate? So basically if you observe, okay, you can observe one pattern over here. Okay, I can say that a pattern here is, so basically there will be 2 solutions which are very basic without using any dynamic programming and all. So these one is bit manipulation solution, and another solution is using recursion backtracking. Okay, so first we'll see bit manipulation solution and then we'll try to write the recursion wala. So let's see. Okay, so then after we'll submit the both the solutions and then we'll try to understand which one is better and which one has more drawbacks. Okay, so first thing that you need to observe is you will be having 8 subsets. Okay, just remember this board. So if I am so if I have given 1 comma 2 comma 3, so here at each and every element I will be having 2 choices, right? I will be having 2 choices. So either I can pick up this element or I cannot pick up this element. Like if I choose to pick this element, okay, if I choose to have that number in my subset, that is one option. And if I decide not to have, that is also one option. So then again same goes with this number 2 as well, then 3 as well. So for that I can say that for each and every number there are two possibilities. One is pick and another one is not pick. Okay, so I can say that if I pick I will say 1, if I not picking I can say that it's going to be 0. So in that case let's try to represent these numbers. Okay, so here my number is all are empty. It means that I wish not to pick up any number. So this, now here 1, so it means that I have picked this particular guy, so I will say 1 0 0. Then here I have chosen 2 here, then I will say this, and here I have chosen 3, so I will say 0 0 1, and here I have chosen 1 and 2, so these two. Okay, it is going to be 1 1 0, and here I have chosen last 2, and here first one and last one, and here I have chosen all. So this is what it represents, right? If I have converted these things into the pick and non-pick. So if you observe carefully, okay, so all these numbers are going to be an numbers from 0 to 7. Okay, let's try to understand. So it is going to be 0, then it is going to be, let's try to find where 1, then 2, then 3, then 4 5 6. Okay, sorry, it is, yeah, it is 6, it is 5, and it is 7. Yes, we got all the numbers starting from 0 until the 7. Okay, so it means that, okay, after seeing this particular guy, like after observing these many cases, I can understand that if I were able to generate all the binary representations of starting with 0 till the 2 power n, which is exclusive 2 power n, then I can have my answer. So like let's assume I have generated the binary numbers as well. Okay, I have generated the binary numbers. So now how can I know whether that particular number, okay, whether that particular number is a set or not, like it means that it is 1 or not. So for that I can say it's very simple. Okay, if you know what is bit manipulations earlier, then it is going to be just, so let's say if I have this number which is 3, okay, so for 3 0 1 1. So now if I wanted to check what are all the bits which are a set, how can I check? So basically whenever you do set and set, like and operation, so you are going to get the 1, right? And if I have done any set operation between 0 and 1, it is going to be 0. So with this thing, if we get an output as 1, it means that at the both the sides we are having 1. If I have a 0 in my answer, it means that in one end I am going to have a 0. So with this technique we can easily represent, okay, we can easily know whether our bit is set or not. Okay, so what I will do now, so every time I will put a 1. Okay, first I will put 1 here. Okay, then I will check. So if I get an element which is not 0 here, okay, if I get a 1, then it means that yes, it is not an 0, so I will include that number. And if I have then I need to go and check here, right? Now at that point, now what I can do, so I can move my like I will move this. Okay, I will take a 0 0 1. So I will continue to move towards right shift. Okay, I will do right shift. So first I will have here, then what I will do, I will make it like to the next element, right? Next element. So sorry, it is going to be a left shift. Okay, so towards left. Okay, towards left. So I will dump this one and I will add another 0 here. So I can have a right. Okay, I can have a set in the second digit. Now if I wish to, if I move another, if I do another left shift, it is going to be 100. So this is how I can move one bit at a time, right? So this is what we need. Okay, let me summarize what we are doing here. Okay, first we are iterating through a loop I is equal to 0 to 2 power n. Okay, then we will be moving our points. Okay, we will be moving our bits and keep on checking, putting one at the some point. Okay, so let's say I will be at how many bits I need to move. Is it going to be how many elements that there are? Yes, right? So 0 to n. Now I will put a if condition. Okay, so if the number which I have currently and one bit, like one left shift, if it is equal to 1, if it is not equal to 0, okay, if it is not equal to 0, I will enter this and I will take that guy, like I decided to pick that if it is 1. So here I will maintain a temp vector. So if it is a 1, then temp dot pushback, I will push that particular index number. Okay, so index of j element, so nums of j, right? So at the end I will be maintaining one result which is an vector of vector 2D, two dimensional. So at the after coming out of this particular loop I will say result dot pushback a temp vector. So this is how a bit manipulation solution works. Okay, coming to time complexity and space complexity. So here we are iterating an external loop for the 2 power n times and then internal loop for the n times. So n. So we know that bit manipulation operations takes a constant time, which is an big O of 1. So I can say that overall complexity is big O of 2 power n into n. Okay, and what about a space complexity? So here we are using an two-dimensional vector, okay, to store our all the subsets. Okay, the size of this particular two-dimensional vector is going to be, again it is going to be 2 power n, like 2 power n subsets, right? So 2 power n rows, and at max it is going to be n columns as well. Okay, at max. So it is the space, and here we are using another temporary space for each computation, right? So it is also going to be at max a big O of n. So this is the space and this is the time. So let's go and we'll try to submit the particular solution and we'll see whether if it is get accepted or not. Okay, so if people feel that the 2 power n itself is a more complexity. Okay, and here we are doing again n. Okay, so let's see. Let me increase the screen size. Yeah. So let's take first vector of store our results. Of the n, then we'll iterate for I is equal to 0 to I less than 1 right shift n. So why did I do that one right shift sorry left shift n? So basically the general formula for left shift is going to be basically, yeah. So if we are moving n bits at a time, like let's say so yeah, it is going to be always 2 power n. Okay, 2 power n. So like let's say if I have my n is equal to 3, okay, and I'm moving, I know that 0 0 1. Okay, so at a first moving a first bit, what I will get 0 0 1 0, and at this second bit I will be like second move, so this is 1, this is 2, so I will get 1 0 0, right? Now I will get 1 0 0 0. Now what is the value? So I'm done with 3 iterations. What is the value now? It is going to be 8. So it's just a fact. Okay, the fact is that all the 2 power n values is going to be um whatever the values we are like it's an all the values are in 2 power n only, right? Like starts from 2 power 0, 2 power 1, 2 power 2, 2 power 3. So we know that all the values are going to be 2 powers only. Okay, so if we want 2 power, we will put 1 over there, and will rest of the things will go as a zeros only. So with that fact, we can say that. Okay, so you can solve another problem here as well. So check whether a given number is 2 powers or not, kind of thing. Okay, so now, yeah, now, so I plus plus, so each time we are considering that, then we need a temporary vector. Okay, where we can store each of the subset, and then we'll iterate for j equal to I and j less than n, j plus plus. Okay, we'll check if I and 1 left. Yeah. So if it is not equal to a 0, if it is not equal to 0, it means that there's some value. Okay, so I will say temporary dot, like temp dot push back the answer, right? So like whatever the value we are holding at that particular jth index. So after coming out of that particular loop, you can say result dot the temp, okay, to store all the subsets we have. Then after coming out of this loop, we can say return a result. Okay, let's try to submit this up. Yes, we got the wrong answer. So what is happened? Okay, just my bad. So yeah, we got it got accepted, and you can see I've submitted multiple times with the multiple solutions. Okay, so we can see that. So now let's go and discuss the recursion solution as well. Okay, recursion solution. So why we think this works as a recursion? So basically there is a fact called whenever there is a question based upon the choice, whether a pick or not pick, we can do, okay, we can do that, those kind of problems using recursion, and then later on to optimize them we can convert them to the dynamic programming as well, but as of now we are not doing that. Okay, so let's go and understand how this works in a recursion. So basically we will be taking, let's try to draw the recursion tree. So at max we will be standing at the this element called a zeroth index, and then we are keeping on maintaining the temporary vector, okay, to store our temporary results. So at first I haven't picked up any guy. Okay, so it is going to be empty. Now I am currently at the first index, and what are the choices I have, whether I can pick up that element, not pick up. So let's say pick up this side and not pick up this side. Okay, now if I decide to pick up that element, then I need to move on to the next element. So plus, okay, 0 plus 1 is going to be 1. Then in my temporary I will be having 3, right? So if I decide not to pick up that, then it is going to be 1 again, but this time empty. So let's go and do string the tree in this particular way. So now again I have two choices. One is pick up, and then if I pick up that element, then it is going to be, sorry, here it's 1, okay, sorry, then it is going to be 2 1 1. Okay, again I will come back to the call. Again I can say I will pick up the element. So it is going to be now okay, so here I have at currently at here, then I'm currently at here. Now I will be moving on to the third index, and at this point of the time I will be having 1 2 3, right? So here whenever we can't go the further, right? Why? So whenever there is an element which is beyond our x, like numbers in an array, right? So here that max we can have 2 1 0, means at 3 elements. Okay, we are reaching our n max. So I can say that stop it here. Okay, stop it here, you can't go further. And whatever you have in the temporary in your data structure currently, just put it in our result. Okay, so in our result then we will be having 1 comma 2 comma 3. Okay, then I will go back. Okay, I will go back to the top, then I will move on to the not pickup side. So whenever I am going back to the top, what do I am doing here? I am doing the pop of the element, right? So here I will be having 1 2 3 elements. Okay, so whenever I am moving on the top, I will be having only 1 comma 2 elements. So I should pop the element which is a back, right? Vector pop back. So whenever I am moving on, like first we'll push that element and do the recursive call same as pickup. Then after completing that particular task, we will be doing pop back. Okay, and then we will be repeating with the not pickup guy. Okay, so here if I say that, then I will move the things to the next index, and I will be having only 1 and 2. So here again I have seen 3, so which is exceeding our limit, so I can't go further. But so before doing that, just put whatever you have in your vector into the result. So it is going to be 1 comma 2. Okay, done. I will go here, then from here I will go. Now here I am done with pickup side, and then I will say not pickup. So if I am not picking up, then it is going to be 2 comma 1 itself. Okay, so again I have another two choices here. I can pick up, not pick up. So I will pick up. If I pick up 3 comma second index, so it is 3, so 1 comma 3. Now again I can't go further, so I will put this in my result 1 comma 3. So and go will top pop back, then 3 comma 1 itself. So I can't go further again, so I will put this one. Now I'm done here. So I will go here. Now from here I have to do this guy. So again I have two choices here. I can pick up, not pick up. So if I decide to pick up, then it is going to be pick up the one guy. So I will have 2. Then again I can have 3. Then pick up, right? So 2 comma 3. So I can't go further. So I will put this in my result. So I will go to the top, and then I will have 3 and 2, not pick up this side. So again it is going to be 2. Done. Now again I will go to the top, and I will shrink at the not pickup side. So it is going to be 2 and same empty. Now again I will have 3 comma, I can pick up the second guy, right? So which is 3. So I will put this in my result. So if I decide go here, it is going to be empty. So I can't go further, so I will put this empty. here. Done. Okay, I will return. So this is how it should work. Okay, so if you can see, just compare whether you got all the subsets or not. So 1 2 3 4 5 6 7 8. Okay, you got all the subsets. So here, but not in the order, right? But even in question they have mentioned that order doesn't matter. Okay, order doesn't matter. So now we'll try to go and submit this particular solution. So yeah, so we need a result. Okay, let me erase everything, and let's say n is equal to nums dot size. Then we required a vector which is a temp. Then let's just return our result here. So our result is going to be a global, okay, vector which maintains our results. Okay, so before returning that, we should helper. Okay, so I'm naming it as a helper, and then I should pass 0, and it will be our size and nums, and the temporary. Now I will go and create the which is helper, which is going to be an void type. So we are not expecting anything to be returned. So index and n and a vector nums and vector a temporary. Now what will be our base case? So whenever our index has uh, been greater than or equal to n, then we should stop. So while stopping, we just push back our temp, whatever we have in temp, to the result, and then we'll return. Okay, so return with some void, so we don't return any number, just an empty return. Then in all other cases, first we need to push back whatever we have currently to the vector, and then we keep on going picking upside. Okay, so it is going to be temporary dot element which I'm currently having. Then helper, so I should say index plus 1, then same, and then nums. Okay, I will do this. Then after coming back, okay, after coming back means going back, so we need to backtrack. Okay, so temp dot pop back, and then it is going to be index, or sorry, so pop back. So then helper, so again helper, we don't need to consider any number, so n then nums for temporary, that's it. Okay, so hope it will accept this. Okay, let's see. Let's go and submit this up. Yes, so it got submitted, and you can see the timings, like so timings in LeetCode, timings are not as same as exactly what it means. So but you can see the memory. Okay, so in first solution it took 7.3 memory, and in second solution it got 17 MB. So here, as you all know that in recursion, okay, in recursion the time complexity is going to be it's in two choices, so it is going to be 2 power n, big O of 2 power n, and we are not doing any extra thing here. And then coming to space complexity, it's again going to be big O of 2 power n into n. Okay, and then extra space here, extra stack space. Okay, so this is the time complexity of recursion. And as we discussed earlier about bit manipulation solution, TC time complexity is going to be big O of n into 2 power n. Okay, then space complexity is going to be this thing. Okay, so big O of 2 power n into n, and we have used one temporary memory, so temporary, so it is going to be again big O of n. So here also we have used that, so yeah, big O of n. So this is the overall time complexities which we have submitted, and like since it is an uh, they have the constraints are too less because they have given only less than or equal to 10 of our nums array size, so it will accept the exponential solution as well, so that's why. And yeah, I guess they have another problem called subsets of 2, so which has some good test cases, so go and keep trying that. Okay, so we'll discuss that particular solution in another video. Okay, so as of now this particular entire video has been dedicated for February daily challenge only. So yep. Let's have another problem in the daily February daily challenge. Okay, so this time the problem name is a maximum depth of a binary tree. Okay, maximum depth of binary tree. So it is an easy level problem. Okay, if you are a beginners to the trees, then this is the problem that you need to look after. Okay, so similar to this you can solve height of a binary tree as well. Like if you are able to understand this particular problem, you can solve that as well. So yeah, I highly recommend you guys to watch this problem and that till the last. Okay, so that you can get some good amount of time. Okay, so the problem statement will be given something like this. Okay, given the root of a binary tree, okay, return its maximum depth. Okay, so what is a depth? Okay, let's see, they have given some intro as well. So a binary tree's a maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Okay, so they are stating that you will be starting from the root. Okay, then you need to reach the any of the leaf nodes. Okay, which is going to be maximum path. Okay, from the starting from the root till the leaf. Okay, then the amount of nodes that involved in that particular path are going to be the maximum depth. Okay, let's say here the leaves are this one and this one. Now if I calculated this particular path, then how many nodes were there? So I can say that there were 3 nodes. And if I consider this particular path, again 3 nodes. If I consider this path, 2 nodes. So I can say that the maximum depth of this particular tree is going to be 3. Right, so this is what a maximum depth means. Okay, so let's see what is another example as well. And so they have given a null. Okay, so it is going to be 2, like it is something like 1 and 2. Okay, so we will be having only one path which is containing only 2 nodes, right? So this is the answer for this particular input. Now pause the video for a while. Okay, think. Okay, so here we will be need to visit all the nodes of a tree for sure, right? So now think in that manner how you are going to get the maximum one. Okay, so yeah. Okay, so we'll take one example of tree, then we'll try to assume what we can do with that thing. So let's say we have something like 1 2 3 4 5 6 7. Okay, so this is the tree that they have given to us. Okay, now how can we find the maximum depth? So just assume, so if we have only one node, if this is the node, what is the path, what is the maximum depth? So I can say that one node. Why? Both the trees are, both the left side and right side are empty. Okay, we don't have any ones. Okay, we don't have any nodes, so the height of the left subtree, okay, depth of the left subtree is going to be 0, at the same time it is also going to be 0. Now let's assume if you have some other nodes as well. Okay, let's say we have 1 2 3 here and 1 2 here. Now tell me which one do you consider one as a, which one is the longest. Now let's say, so I am standing at here. Okay, I'm standing at here. Now I can say that there were two possibles here. So either I can go left and I can go right. So left subtree and right subtree. Okay, now just assume, so till now here we got 1 and here we got 1. Now I will be going here. So here again I will be getting 1. So I will took up 1. So this particular path I will be getting 3 nodes. Okay, which is like if I consider left subtree, I will be getting 2 as my count. If I consider right subtree, I will be getting 1 as my count. So which one so I need a maximum. So which one do I need to consider now? I need to consider which is giving me the maximum. So max of left subtree comma right subtree. Yes. So if I consider max of both, then I need to add that a maximum one with the root node as well, which I need to consider that. So I will add +1. That's it, my answer. Still you are not able to believe that? Okay, let's try to understand. Okay, now let's say we have given this particular tree. Now let's try to generate for this thing. Now first I am standing here. I will just check whether this particular node is empty or not. No, it is not a null. So I will go to the, I need to check, okay, to the both the sides, whether if I have a left thing, then I need to go. If I have a right, then I need to go as well. Okay, so let's assume at first I will go in this way. Okay, now I landed at 2. Okay, I landed at 2. So if I am landed at 2, again I need to repeat the same. I need to go to the left and right. Okay, I will go to the left first. Okay, so this is a depth. Okay, so we are reaching the one path till the end, starting from the root. Okay, so this is called as an DFS. So basically for trees we will be having two traversal techniques, BFS and DFS. In BFS again we do have few other techniques like pre-order, in-order, post-order. Okay, so most of your tree based problems can be solved using either of these approaches, but if you are in an interview you need to justify that why we have chosen this particular order, why not this in order. Okay, so if you are in that particular stage, okay, you need to tell that as well. So that's what an intuition comes into picture. So solving knowing intuition is a way more important than just solving the problem. Okay, so now we are going into an depth-wise manner. We are traversing to the left side first. Okay, you can traverse to the right as well. So in our case it doesn't matter, so you can either choose pre or post. Okay, no matter. So now we have reached to 4. Okay, so when I have reached to 4, I will be traversing to the left. So whenever I have seen to the left, there is nothing here. Okay, so I will return just a 0, and then I will go to the right side. So when I have reached to right side, there is nothing again, so I will just return 0. Okay, so from this particular node I got a left as 0, right as 0. So if I consider the maximum of them, so it is going to be 0. Okay, if I do +1, it is going to be 1. Means from this 4th node, okay, to come to 4th node we required 1 depth. Okay, so I will return that 1. Now from 2 we need to traverse to at the 5th side. Okay, right side. Okay, so I will traverse here. Okay, so after 5 then I will check left and right. So I have left, so I will go here, and again for 6 there is nothing onto the left and right, so I will return 0 0. So max of 0 comma 0 is going to be 0, then it is +1, so I will return +1 here. Okay, Now I will go on to the right side, so there is nothing 0, so I will return 0. So maximum of 1 and 0 is going to be 1, so I will return 1. Then I need to add 1 for this 5 as well, right? So I will return 2 here. Now for 2, after considering right and left subtrees, have and values of left side as 1, right side as 2. Now which one do I need to consider? The one which is giving me the maximum. So that 2, I will consider the 2. Now after, if I consider 2, then I need to add the 1 for this current node. Okay, I will return 3. Okay, I will return 3. Now I'm done with the left subtree. Now I will traverse to the right side. So from 1 I will go here. Okay, then I will move on to the left and right. So for right, for left it is 0, for right it is going to have right. Then for 7, both the left and right are 0, so I will return 1 here. Okay, after going to back to the 3 node, then I have a 0 and 1, so it is the maximum of 0 and 1 is 1, so I will do plus 1, so I will return 2 here. Now I have 3 and 2. Now which one do I need to consider? The one which is a very maximum one. The maximum is 3, right? Maximum is 3, so I will do plus 1. Okay, I will do plus 1, so I will, at the end I will return 4 as my answer. Okay, 4 as my answer. So that is the maximum one, right? So this is the path. Okay, this is the path which is a maximum. So this is the path. So 4 nodes. Okay, so you should return 4 as your answer. So how did we wrote this particular code? Okay, so let's go and try to code this up. Let's assume we have a function called max depth and you will be given root. Okay, then first you need to check whether that given a root is null or not. If it is null, what you need to return? If it is null, you need to return 0. Sorry, okay, 0. Now else you need to do 2 operations. Either you need to go to the left subtree and right subtree. Okay, so int left subtree is equal to, again, max depth of root of a left. So, and you need to, after completing left side, you need to go to the right side. Okay, max depth of root to the right. And after that, you need to return the maximum out of left and right plus 1. Done. Your answer is done. Right, so let's go and quickly write the code for this particular approach. Before moving on to the code, let's try to analyze the space and time complexity here itself. Okay, so if you see, we are traversing to all the nodes at once. We are not traversing twice or thrice. Okay, so we are traversing only once, so it is going to be a big O of number of nodes. Okay, and coming to the space complexity, we are not using any explicit space, but we are using a stack space because it's an recursive based solution. It uses a stack memory. So for most of the tree based solutions, if you are using DFS traversal, then it is going to be big O of log n, because at the same time you will be keeping off of your tree. Okay, off of the either left subtree or right subtree. Okay, you are not keeping whole nodes, right? So it is going to be only off, so it is going to be log base to n. Now let's go and try to write the code for this. So if root equal to null, you should return a 0, right? Else you need to traverse to the left side. So left side is going to be again max depth of root left. Okay, and again right is going to be max depth of root of right. Then at the end you should return max of left comma a right, okay, plus 1. Now let's execute this. I think it should accept. Yeah, I've submitted this couple of times. Okay, while I was preparing for my interviews. Yeah, faster than 85%. Yeah. So see, here I have submitted for the first time it got 8 seconds, and then second time 22 seconds, then now it's again 7 seconds. So there is another solution as well. If you are not fond of this DFS kind of solution which uses recursion, there is another solution based out of BFS type of solution. So yeah, I will discuss that as well. So which is not an recursive based solution. So it is going to be an BFS based solution. So BFS means you will be considering breadth wise. Okay, so why this particular BFS works? Okay, why this particular BFS solution work? I will tell you the intuition. Okay, so let's say if you have a tree something like this, 1 2 3 4 5 6 and 7. Okay, and here it has 8. Okay, now what is the maximum depth of this tree? So I can say that 2 5 6 7, so it is going to be 5. So the answer is 5. So why it is 5? So if I consider levels, how many levels are there? 1 2 3 4 5. Okay, I have 5 levels. So can I say the number of levels equal to maximum depth? Yes, that is one kind of solution that we can do. So we need a breadth wise. Okay, breadth wise. So a depth means you are traversing to the vertically, breadth means you are traversing horizontally. Okay, so here in this case you need to traverse horizontally. It means that whenever you are at current level, you need to consider all the trees. That's it. Okay, so is there any such type of algorithm that you can come up with? Yes, there is a BFS. Okay, so basically BFS uses a queue data structure. Okay, queue data structure. So what it will do? So first it will take this first root node and kept this in the queue. Now every time while you are iterating, so you need to iterate till the queue becomes empty. So when this queue becomes empty, so whenever there is no nodes to traverse. Okay, so basically the idea here is you will enter into the loop. Okay, and you will push all the right and left subtrees of the node, current node which you are standing at. Then you will add up the breadth. Okay, so let's say first I have so let's say I will have a max depth variable as well, which is going to be a 0 at first. Now I will go and traverse for the size of the queue. So here the size is 1. Okay, the size is 1, so I will iterate over the one time. So I will add all the right and left subtrees of a particular node. So for 1 2 and so this particular is done now. So we'll add these 2 and 3. So first I will add 2, then 3. Now again I will come to the loop and then I will check again my queue is not empty. So I will take this 2 now. Okay, and I will add this. Okay, add increment. So in the beginning I have incremented to the 1. Now I will increment to the 2. Okay, means I'm currently at second level. So now I will iterate over the queue until this queue times. Okay, so here the queue size is 2. So I will iterate over the 2 times and I will add all the 2 right and left subtrees, 3 right and left sub nodes. Okay, so for 2 this is going to be 4 and 5. So I will add a 4, then 5, and I will erase this 2. Now for 3 I will add 8 and erase this. Done. So for that I can think that I can have completed the thrall level as well. Now the queue size is 3, so which means that whatever the elements which are there in the queue now, I need to find the all the nodes which are left and right of the current nodes, like all these three. Then I need to add them to the queue and I need to erase them the current nodes. Okay, so for 4 there is nothing, so I'll eliminate that. For 5 we have 6. Okay, and for 8 nothing, so I'll erase that. So I will increment it to the 4, means I have completed the level 4 as well. Now I will take out this 6. Okay, then add this 7 to the queue and erase this. Now I will take out this, and after there I can see that there is nothing for the 7, so I will come out of the loop. So, and if I see my max depth is the 5, right? So what is the intuition why this particular thing is working here? So if you observe, at each time I'm just taking care of, I'm pushing all the current level, current breadth nodes to the queue. Okay, so in that case I can say that I am traversing only for the breadth times, means level times. So indirectly it means that a number of levels is equal to max depth, right? So with that use case we have solved this problem. So let's quickly go and try to write the code for this. Okay, so for that yeah, okay. So first we can check that whether a root equal to null or not. If it is null, we can simply return 0, and if it is not null, it means that we need to push that to the queue. So let's create a queue here, which is a type of tree node. Okay, tree node queue, and then I will push that root node, and I will check whether, like, I will iterate over queue is empty. Okay, so now until this queue not empty. So now I need to increment my counter. Okay, so let me define the counter outside. So int max depth equal to 0. Okay, and I need to increment my max depth plus 1 plus plus. Then I need to make sure that I need to iterate over the queue size elements now. So q dot okay, so size equal to q dot a size. Now will be loop until the size minus minus. So now now I can say that if, like, I need to get the top node, so current node equal to the q dot friend. Okay, so whenever I got that node I need to eliminate the top element, so I will pop that out. Then if the current node has a null, like has current node left not equal to the null. Okay, if it is not equal to the null, what do I need to do? I need to add that to my queue. So queue dot push current node left. Okay, so if it is okay, so I am done with left side and I need to check the right side as well. So current node right. Okay, current node right not equal to null. Okay, current node right not equal to the null. I need to add that to the queue. Okay, queue dot okay push current node to the right. Done. So I'm done. So every time it iterates over the size of a queue. Then after coming out of this loop, I need to return the max depth. Okay, sorry, current node we need to get the is going to be tree node, right? Tree node, or you can say Yes, done. So now what is the time complexity of this particular approach? So yes, it is going to be again big O of n, because in this case as well we are iterating through all the nodes at once. So it is going to be big O of number of nodes exist in our current tree. And coming to the space complexity, we are using again big O of n, where n will be our number of nodes. Okay, to store to maintain a queue, right? We are maintaining a queue. So in this case it is going to be say both time and space complexity is going to be big O of a number of nodes, and we are not using any extra memory for our call stack since it's an iterative based solution. So now it's your choice. Okay, I highly recommend the recursive based solutions, but in case if you are in an interview, it is there will be slight chances, so your interviewer might ask you to write the iterative based solutions, because everyone knows that DFS is an little complex because it's an recursive based solution. So yeah, so if you are blunt pre in and post order as well, so try to make sure that you know the iterative based solutions as well. So that's all for this. So hello everyone, let's solve another problem in the February daily lead code challenge. Okay, so the problem name is a single number. A problem number is 136, and it is an easy level problem, and it has 9k likes. Okay, so it means that it's a good problem to solve. Now let's look at the problem statement. Okay, you will be giving you an non-empty array. Okay, non-empty array means a size of the array is going to be must be greater than 1. Okay, and every element appears twice except for one. Okay, so they are telling that in an array every number means every element, okay, every element is going to repeat for twice. Okay, twice except one element. Okay, except one element. So now your job is to find that single element. Okay, so whatever that element which has been occurred only once, you need to figure out that element. Now you must implement a solution with a linear runtime complexity. Use only constant extra space. So they are stating that you need to do this in linear time, which means a big O of n, and use only constant extra time, so which is equivalent to big O of 1. Okay, you are not allowed to use any extra space. Okay, so now I hope you got the question. Okay, so let's see some examples here so that you will get a better picture. And so this is the array they have given, so 2 2 1. Now you can see that 2 has occurred twice and 1 has occurred only once, so here you should return 1 here. Done. Now in this case, if you can observe, 1 has been occurred twice, 2 has been occurred twice, 4 has been occurred only once, so you need to return the 4 now. So here as well, so here you will be having only 1 in your array. In that case, that is the only number that you need to return. Okay, so I hope now you got the point. Okay, like you got the question. So please pause the video for a while. Okay, start thinking about its solution which comes. Okay, now let's go and see what we can do. Okay, let's consider you will be given 1 2 so 4 1 2 4. Okay, or let's replace 3 here and a 3. Okay, sorry, let me pick up another array. Okay, let's say I have a given n now 1 2 3 1 2. Okay, I have given this particular array. Now in this case the output will be 3, right, which is only occurred for once. So now what you can do, so So just think in perspective of brute force. Okay, brute force means a naive approach that comes to your mind. Okay, think in very naive manner. So let's imagine. So just think in very naive manner. Okay, naive. So just imagine, okay, if I am standing at this particular element, okay, if I have picked at this one, now I will check, okay, I will check with the rest of the elements, and if I am able to find an pair, okay, where this one equal to any other number, okay, in that case I can say that yes, there is a pair, like yes, it has been repeated twice, right? So if I am not able to find such guy, okay, with the equivalent element, I can say that this is not going to be repeated. Okay, now let's see, let's try to dry run this particular thing. So I will be standing at one, and I will check at the rest of the elements in the array. Now I can say that yes, one is there. Now I can confirm that one should be not my output. Now I will move on to the next guy, which is 2. Now I will check at the rest of the elements. So yes, I will find an pair with the 2. Now I will check with the 3. So is there any number, okay, with the 3 after 3? No, there is nothing. So that I can say that yes, this is the element which is being occurred only once. Okay, so why this should work? So basically the fact that they have given except one element, every number has been repeated twice. Okay, every number or element repeated twice. Okay, and based upon this particular statement we have given, we will be doing like this. Okay, whenever I haven't got an equivalent element, I can say that this is, yeah, this is the element which I'm looking for. So now how can I write the code? Okay, let's say I will have a one for loop, I is equal to 0 to n, and then I can have another for loop where j equal to I plus 1. Okay, I will be starting from the next element, okay, to the n. Okay, and I will check if nums of I double equal to nums of j. So if it is equal, then I can simply say continue. Okay, I can simply say continue. Now if that is not the case, okay, after coming back, okay, I can say here just we can say that as well, like let's say we can maintain a flag equal to true, so we can define this here, sorry, okay, we can define this here. Now whenever there is a guy which if I found and pair, then I can say that flag equal to false and a break out of this particular loop. Okay, and after coming here I will just check if my flag still equal to true. Okay, what does it mean? It means that I haven't found any equivalent number. Okay, I haven't found any equivalent number. So in that case I can say that yes, just return nums of I. Done. So it should work because there is one element which is being occurred at once for sure. Okay, so after like if you still have doubt, you can return 0 after coming out of the loop. Okay, anyhow it is not going to execute because you will be executing this statement for at least for once for sure. Okay, then not a problem. Now if you can observe the time complexity here, I can clearly say that it is an big O of n power 2 n square. Okay, so but they asked us to do it in the linear time. Okay, linear time. So now think, okay, how to reduce this particular time complexity. So while I was thinking, okay, so I can say that better approach. So let's say it is based upon the counts, like frequency of a numbers, right? Frequency of elements. So whenever there is such cases where you need to find the frequency, then you can blindly go with the map. Okay, unordered or ordered map, that's your according to the problem statement that you can choose that. But in this case order doesn't matter to us. So what I can do, I can traverse through all the elements. Okay, I can do traverse all the elements. So in our case, if I traverse through all the elements, then I can say that for 1 I will have a frequency 2. Okay, for 2 I will have a frequency 2, which is an 2 and a frequency. Okay, and for 3 I will have a frequency 1. Now I will traverse through this particular map now. Okay, and I will just check. Okay, let's say if auto IT, I'm assuming this map as a MP. Okay, and if map dot second, okay, map dot IT dot second is equal to 1, what does it mean? It means that that is the guy which I'm looking for. So return IT dot first. That's it. All you need to do is first you need to keep on maintaining the frequency. So how can you do that? It's just a for loop. Okay, like you can traverse through all the integers in the nums array, which is an input here, and every time you can do simply mp of plus plus. So it will work and it will store the answer in this particular format in the map variable. Now after that, if you can do this, you will get your answer done. Now if you are able to compute the time complexity and space complexity here, you can clearly see that time complexity is going to be big O of n plus big O of n in the worst case. Okay, and a space complexity is again going to be big O of n in the worst case, where all you will be storing all your map elements. But that is not the case, but it is going to be n by 2 for sure. So if you consider the upper bound, you have to commit as a big O of n. So now let's try to solve this problem on the linear time. Okay, as they asked. So linear time means we will be need to do this problem on the single for loop, means one iteration. So can we do that? Yes, but here you need a bit of bit manipulation knowledge. Okay, so bit manipulation knowledge. So I won't bother you much. Okay, so you can say I will give you an hint of XOR operator. XOR. So what does this XOR do? Okay, let's try to write the truth table for this. So let's say if you have two inputs. Okay, if you have two inputs, then let's say 0 and 0, 1 and 0, 0 and 1, and 1 and 1. Now in this case, the output for this particular, if I perform A XOR B, then it is going to be 0, 1, 1, 0. So whenever you get a different inputs or different numbers, then your output is going to be 1. Okay, so based upon this particular logic, we will be solving this particular problem. Okay, now let's say whatever I have my list or array, I will XOR all the elements. So let's say 1 XOR 2, 2 XOR 3, 3 XOR 2, and 2 XOR 1. Now for all, if both inputs are same, then our result is going to be 0, right? Just remember that. So I have this one and this one. I can say that I can replace this one with the 0. So if I do that, this is my output. Now again I can see that this 2 and this 2, I can cancel them and I can replace them with the 0. So 0 0. Now I can again replace these two zeros with the 1 0. Now I have doing an XOR with the other number, right? 0 XOR 3. So if you do 0 with 0 XOR with any number, you will be getting your answer as any number. Okay, still if you are not like believing that, let's say, let me write the bits of these things. Okay, for 3 it is going to be 0 1 1. For 0 it is going to be 0 0 0. So here 0 and 0, oh, sorry, 1 and 0 1, 1 and 0 1, 0 and 0 0. So at the end I will get my answer as a 3. Yes, done. So is this what we are looking for? Yes, this is what we are looking for. Still you might be wondering how this got worked. Okay, and if you need an proof why this has been worked, you need to do these operations all on yourself. Okay, and I'm not asking you much. Okay, so if not, I will do that as well. So at first I will be doing XOR of 1 and 2. So for 2 it is going to be 0 1 0, and for 1 it is going to be 0 0 1. Now if I do XOR of these, then it would be this. Now for this I'm XORing with the 3. Okay, so for 3 0 0 1. Okay, so all were, as of now, all were zeros, like all were same, right? So 0 0 0. Then again I will do with the 1. So 0 0 1. Now I will get 0 0 1. Now I need to do with the 2. So for 2 0 1 0 1 1 0. So I can say that this is my end result, which is 3. Okay, so yes, now you got the proof why it has been working. Now what you can do? Okay, so how to convert this as your programming. So I can say that, let's say I will say int it, and I will traverse through all the numbers in the array, and I will maintain an output which is being initialized to the 0. Now I will perform, okay, XOR of all the operations, like all the elements which I have got. Then I will store the result in my output. So after coming out of this particular loop, my output will be containing the element which is being occurred for once. Okay, and this is how you will be solving your problem. Okay, so you got the intuition, you got the brute force. We started from the brute force approach and we came till the optimized approach. Okay, and this particular problem has a slight variation as well. Okay, so here the given input is unsorted. Okay, unsorted array. And what if, okay, my question, what if you are given an sorted array? Okay, let me know your answer in the comment section. Okay, so what type of algorithm that you are going to use? So don't need to work harder. Okay, I will give you hint: binary search. And if you have solved this problem, please let me know in the comment section. So we always keep an eye on the comment section. So if you have watched it till now, please do subscribe, like this video, and please let us know how did you feel about this particular video, and did you enjoy solving problems on LeetCode? Please let us know in the comment section. So bye. So let's try to submit the programming that we have written so far. Okay, so we have said one thing: int output is equal to 0, then we have iterating to all the array. Then we are doing XOR of all the elements. It is going to be, and then after coming out of the loop, we need to return that output whatever we got so far. Now if I run this code, it is running, and if I submit it, uh, yep, it got submitted. Okay, so now the let's see time complexity and space complexity of this particular approach. So I can say that a time complexity of this approach is going to be big O of n. So since we are doing it in only one iteration, okay, and that too we are iterating for all the elements in an array, and we are not using any extra space, even a map as well. So I can say that it is going to be constant memory. So satisfied for the given conditions. So they asked us to do the problem in linear time and a constant space as well. So done. Okay, so this is how you can solve this particular problem.